What's up, everybody? This is Tech G back with another video. And in this video, I'm going to be explaining to you exactly what artificial intelligence, machine learning, and deep learning is, in case you have no idea. So let's get into it. All right, so you've probably heard the term artificial intelligence or just AI tossed around a million times. Maybe it was in the context of self-driving cars or Siri telling you the weather when you're too lazy to look outside. But what exactly is AI? And how is it different from machine learning or deep learning? So if you've ever felt like these buzzwords are just being thrown around like confetti, well, you're not alone. In this video, I'm going to clear the fog and break it all down in plain English. And no, you do not need a PhD to understand. You just need pure curiosity. Let's start at the top. Artificial intelligence. This is a broad field in computer science focused on building systems that can perform tasks that normally require human intelligence. So think of problem solving, understanding language, recognizing images, making decisions, stuff that your brain does naturally. Now imagine AI as the umbrella term. Underneath it, you'll find different branches and subfields like machine learning, deep learning, natural language processing, computer vision, robotics, and much more. So what is the official definition? Well, AI, this is the simulation of human intelligence in machines that are programmed to think like humans and mimic their actions. But let's keep it real. AI is not about creating robots that'll take over the world, at least not yet. It's about teaching machines to do things like understand spoken or written language, like your voice assistants or chatbots, recognizing images or faces, like Facebook tagging suggestions, playing games and beating human beings at the games, and recognizing what show you would binge watch next, like when you go watch Netflix. So in essence, AI is about getting computers to quote unquote act smart. Exactly how does AI work? Well, at its core, AI works by using algorithms, and these are basically step-by-step instructions to process data, find patterns, and make decisions. And these systems, they need data, rules, and sometimes feedback to improve. And some AI systems are hard-coded. That means programmers give them clear rules like, if this happens, then do this. Others, they learn over time by adjusting their behavior based on data, and that's where machine learning enters the scene. So let's talk about machine learning. Well, machine learning, this is a subset of AI. It's one of the most exciting and powerful tools used in AI today. In simple terms, machine learning is a way for computers to learn from data without being explicitly programmed. So instead of telling the machine every single rule, you feed it tons of data and it figures out the patterns for itself. So let's go over an example real quick. So imagine you're building an email spam filter. Now you could write hundreds of rules. You could have it to where if the subject line says you want a free iPhone, it'll mark it as spam. Or if the email comes from a sketchy domain, it'll flag it. But spammers are clever. They keep changing their tactics. Now with machine learning, you can train a model using thousands or millions of examples of spam and not spam emails. And the algorithm learns what spam looks like and gets better over time. That's essentially machine learning in action. Now let's talk about the different types of machine learning. So there are three main types that you should know. The first is called supervised learning. And this is when you train the model on labeled data. So an example would be predicting house prices that are based on size, location, etc., when you already know the correct prices, i.e. the labels. And the use cases for this could be used in email spam detection, credit scoring, and sentiment analysis. The second type is called unsupervised learning, and this is when the model explores the data and finds hidden patterns without labels. An example of this could be grouping customers by purchasing behavior, and the use case could be customer segmentation or anomaly detection. And then we have what is called reinforcement learning. And this is when the model learns by trial and error and gets rewarded or gets penalized. An example could be teaching a robot to walk or training AI to play video games. And use cases for this would be obviously in robotics, recommendation systems, and game playing AIs. So now that we got that out of the way, where exactly does deep learning fit into all of this? So deep learning, this is a subset of machine learning. It uses complex structures called neural networks, which are inspired by how the human brain works. And these networks have multiple layers, hence the name deep. In deep learning, this is what powers many of the most impressive AI feats today, such as self-driving cars that can recognize stop signs or Siri understanding your voice. Now, the key strength of deep learning is that it can automatically extract features from raw data. So instead of manually telling it what to look for, it figures it out on its own. So here's an example of deep learning in action. So let's say you want an AI to recognize cats in images. With traditional machine learning, you'd have to extract features manually, like is the shape cat-like, are there whiskers, are the ears pointy? With deep learning, you feed the algorithm raw pixel data from thousands of cat and non-cat images, and the neural network learns what features make up a cat without being told. And it's pretty much like magic. Well, data-driven magic, I should say. Now, if you're still lost as it relates to the relationship between AI, machine learning, and deep learning, here's a visual to help you understand. All deep learning is machine learning. All machine learning is artificial intelligence, but not all AI is machine learning or deep learning. Now, if you're still lost, here's another analogy to hopefully drive this point home. Now, imagine you're trying to make a smart pizza making robot. And AI is the goal. So you want the robot to make decisions like a human chef. Machine learning, this helps the robot, quote unquote, learn what combinations of ingredients taste good by analyzing thousands of customer reviews. In deep learning, this allows the robot to, quote unquote, see what a perfectly baked pizza looks like by analyzing thousands of pictures and automatically learning the features such as the crust color, cheese melt, etc. Now, there are some other subfields of AI. So while machine learning and deep learning, they get all the hype, AI is bigger than that. And here are a few other key areas. So you have what is called natural language processing. And this is how machines understand and generate human language. So think about chatbots, language translation, or summarizing a long article into one sentence. Then you have what is called computer vision. This field deals with teaching machines to interpret and understand visual data like images or video. This is what powers facial recognition or object detection in photos. And we have robotics. So AI and robotics, this is used to help machines perceive, plan, and act. And robots, they can clean floors, deliver packages, or perform surgeries. And then there's what is called an expert system. And these are rule-based systems designed to mimic the decision-making ability of a human expert, especially in fields like medicine or law. So now that we have a general understanding of what AI is, let's talk about what AI is not. So first things first, AI is not just a single program or device. This is an entire field. AI is not perfect. It makes mistakes. Sometimes they're hilarious and sometimes they're serious. AI is not conscious or self-aware, despite what science fiction may tell you. And AI is not always learning. Some systems are static and they do not improve over time. Now, here's a chart right here that breaks down the differences between AI, machine learning, and deep learning, in case you want to check this out and get this in your life. So now that we've gone through all of that, why does any of this even matter? So understanding the differences between AI, machine learning, and deep learning, this isn't just about sounding smart at parties, although this will probably help you sound real cool if you did. This helps you grasp what's happening behind the technology that you use every single day. It helps you think critically about AI's potential and its limits. It helps you navigate careers in AI-related fields, and it helps separate hype from reality in tech news. So whether you're coding the next killer AI application or just trying to make sense of what machine learning powered actually means on a product label, this foundation is everything. All right, so let's go ahead and wrap all this up. AI is the big picture. This is machines doing smart stuff. Machine learning is the toolkit that helps machines learn from data. And deep learning is the deep end of machine learning, where it uses neural networks to solve complex problems. Now, as we continue with this AI fundamentals course, we're going to dive deeper into how these systems are built, how they're used in the real world, and the ethical questions we need to consider when machines start making decisions for us. But for now, just go ahead and pat yourself on the back, because you've just unraveled one of the most confusing parts of the AI world. And with that being said, let's do some check on learning to see if you were paying attention. So the first question is, which of the following best defines artificial intelligence? Is it a set of rules manually programmed to perform repetitive tasks? Is it the ability of a computer system to perform tasks that typically require human intelligence? Is it the process of training a model on data to recognize patterns? Or is it a neural network that mimics the structure of the human brain? And the correct answer is, it is the ability of a computer system to perform tasks that typically require human intelligence. So AI, this refers to the broader concept of machines being able to carry out tasks in a way that we would consider quote unquote smart, such as reasoning, learning, problem solving, understanding language, and recognizing images. Next question. How does machine learning differ from general artificial intelligence? Is it machine learning refers to manually coding rules while AI is based on automatic learning? Is it machine learning is a type of AI where machines learn from data without being explicitly programmed? Is it AI is a subset of machine learning that is focused on vision and language? Or is it machine learning is only used in robotics and not in virtual assistants? And the correct answer is machine learning. This is a type of AI where machines learn from data without being explicitly programmed. So, machine learning, this is a subset of artificial intelligence. Now, while AI encompasses any technique enabling machines to mimic human behavior, machine learning focuses specifically on algorithms that allow systems to learn from and make decisions based on data. And our final question, what is deep learning primarily characterized by? Is it rule-based logic that improves with human feedback? Is it the use of statistical formulas to create random decision trees? Is it a subset of machine learning that uses multi-layered neural networks to model complex patterns? Or is it algorithms that only work on small structured data sets? And the correct answer is this is a subset of machine learning that uses multi-layered neural networks to model complex patterns. So deep learning, this is a subset of machine learning that involves neural networks with many layers. It excels at processing large and complex data sets, such as images and natural language. And this is the foundation for advanced applications like self-driving cars and voice recognition. All right, so let's kick things off way back. The idea of creating intelligent, human like machines isn't new at all. Ancient civilizations were already fantasizing about this. As it relates to Greek mythology, there are stories from Homer that talk about intelligent statues and golden robots. And there's some god with some crazy name out there I can't pronounce that supposedly built mechanical servants. And all that sounds creepy, but maybe it's just futuristic. Who knows? And then there's also the Jewish golem legend. So in Jewish folklore, a golem, this is a clay creature that's brought to life to protect people. And it was an early version of an artificial human. Anyways, these stories didn't involve silicon chips or algorithms, but they reflected a basic human desire, and that is to build things in our image that can think and act for us. Now, fast forwarding a few thousand years to the thinkers who started making the dream a bit more realistic. The first person is a dude named Rene Descartes, and he had the mind body question. So basically, Descartes, I think that's how you say his name, but anyways, he proposed that the human body was like a machine and that thought was a separate process. And this opened up philosophical debates about whether machines could one day think for themselves. And then you got a guy named Gottfried Leibniz. I think that's how you say his name. But in the late 1600s, this guy imagined a universal language of logic, which is an idea that would later inspire programming languages and AI logic systems. And then we roll into the 1800s, and there's a person named Charles Babbage and a lady named Ada Lovelace. So Charles Babbage, he designed what is called the analytical engine, which is what you're looking at on your screen right here. And this was the first concept of a programmable machine. And then a lady named Ada Lovelace, she is considered the world's first computer programmer. She theorized that Babbage's machine could do more than math, that it could even compose music if programmed correctly. Now, obviously, back in the 1800s, they didn't have the hardware to make all of this happen, but they did have the vision. All right, so let's go ahead and jump to the 1930s and 1940s, and this is considered the birth of computing and theoretical AI. So in 1936, a guy named Alan Turing, he published a paper that laid the foundation of computer science. He described a theoretical machine, which is now called a Turing machine, that can simulate the logic of any computer algorithm. And then during World War II, Turing, he helped crack the Nazi Enigma code using an early electromechanical computer. But it was in 1950 that Turing really hit the AI scene with his paper called Computing, Machinery, and Intelligence. He posed the now famous question, which stated, can machines think? And then he also introduced what is called the Turing test. And this is basically if a machine could converse with a human without the human realizing it's a machine, then he would consider the machine to be intelligent. And as a spoiler alert, we're still chasing that goal today. Moving forward to 1956, this is considered the official birth of AI. And then within that, we have what's called the Dartmouth Conference. And this is the moment most historians call the official birth of AI. So in 1956, John McCarthy, a guy named Marvin Minsky, another guy named Alan Newell, a guy named Herbert Simon, and others that gathered at Dartmouth College for a summer workshop. And McCarthy, he coined the term artificial intelligence. And all of these guys, they propose that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine could be made to simulate it. Now, that statement was bold and perhaps a bit premature, but that statement is what sparked a movement. All right, so moving forward to the 1950s and the 1960s, this is when the first AI programs came about. So after Dartmouth, things started moving fast. So in 1955, we have what is called the logic theorists, and this was built by Newell and Simon. And the program, this could prove mathematical theorems and was called the first artificial intelligence program. But in 1957, you have what is called the General Program Solver. This is another Newell and Simon project, and this could solve a wide range of logic programs using rules and a goal-directed approach. Then in 1966, you have what is called ELIZA, and this was developed by a guy named Joseph Weizenbaum, and this is one of the first chatbots. And this simulated a therapist by reflecting questions back at users. So for example, the user would say, "I'm sad," and Eliza would respond by saying, "Why are you sad?" Now, this is not truly intelligent, but it was very convincing for its time. And also during this time period, people started to think that machines could be almost human, but this optimism wouldn't last forever. Then comes the 1970s, and we have the first AI winter. So exactly what happened. So basically, researchers, they had made bold predictions in the 60s and early 70s that AI would soon outperform humans in everything. Well, as we all know, that didn't happen. And some of the reasons why this didn't happen is because computers were still too slow and expensive back then. AI systems, they couldn't handle real world problems very well. And more importantly, funding had dried up when the hype didn't deliver. So governments and companies, they pulled back support, and basically the AI party was over, at least for now. All right, so moving forward to the 1980s, AI had bounced back thanks to something called expert systems. So what is an expert system? Well, these were rule-based programs designed to mimic the decision-making of human experts. You have examples like NYCIN, and this was created to diagnose bacterial infections. It used if-then rules to simulate how a doctor might think. Now, why exactly was there a comeback? Well, these systems had real-world use in business and healthcare, and corporations saw the value and started investing, but it didn't last forever. As the systems grew, they became hard to maintain and the magic faded again. And then we headed into what is called the second AI winter. And this took place in the late 1980s going into the 1990s. So once again, the hype train had crashed. And the reasons are expert systems, they couldn't scale, they couldn't learn from new data, maintenance was expensive. Once again, funding dried up. And this second winter was colder and lasted longer. But in the shadows, something new was brewing. All right, so moving forward to 1997, we have an AI program called Deep Blue that beat a guy named Gary Kasparov. And this was a huge moment. So IBM's Deep Blue, it defeated the world chess champion Gary Kasparov in a 6-game match. And here's why this mattered. Well, it showed that AI could beat the best human in a complex game. And Deep Blue didn't just think like a human, they used brute force and strategy, but it was proof that machines could win in elite level cognitive challenges, and that turned heads once again. Then we get into the 2000s, and this is the rise of data and machine learning. So essentially, we're in the internet era where two key things change the game. The first is massive amounts of data. So we started generating data at an unimaginable scale. We're talking emails, social media, photos, video, and online behavior. And also computing became cheaper and faster. So Moore's law and cloud computing, this made it easier to process all of this data. And as a result, a new wave of AI powered by machine learning came about. So instead of hand coding rules, developers, they trained models to learn from data. Fast forward to the year 2012, and deep learning changes everything. So in 2012, a neural network called AlexNet, it crushed the ImagineNet competition, which was an actual challenge where computers try to identify objects and images. And AlexNet used deep learning, which is a type of machine learning that mimics the human brain using layers of artificial neurons. Now, why was this a big deal? Well, it cut the error rate in half. It reignited global interest in AI, and it showed that deep learning could outperform traditional methods. So basically, this is what kicked off the modern AI boom that we are now experiencing. All right, moving forward to 2016, you have AlphaGo. This beats the Go Masters. So you might have heard about chess, but what do you know about this game called Go? Well, this is a 2,500-year-old Chinese board game known for its complexity. And humans, they were unbeatable until AI showed up. So you had this competition called AlphaGo, which was hosted by DeepMind, which is Google's AI company. And essentially, it beat the world champion, some guy named Lee Sedol, in 2016. Now, it didn't just win, it made creative moves that no human had ever thought of. And this was a turning point. So basically, AI can now master tasks that required intuition and creativity. And then that brings us to the year 2018 all the way to the present, and AI is everywhere. So now we are living in the AI renaissance. So let's go ahead and look at some recent milestones. So we got the GPT models created by OpenAI. So GPT-2, which was created back in 2019, this started generating realistic text. You got GPT-3, which came out in 2020, and this had 175 billion parameters with very good fluency. And then we got what is now known as ChatGPT, and this brought AI to the masses, sparking worldwide conversation about AI's role in work, education, and society. Also, there was Dolly and Midjourney. So AI can now generate images from text prompts like a cat riding a skateboard in space. And then we also have AI applications being used in real life. So in healthcare, they can diagnose diseases from x-rays. In finance, they can detect fraud and make stock predictions. In transportation, we have self-driving cars. And entertainment, we use AI in Netflix and YouTube recommendations. And we also use AI in education as far as personalized learning tools. So now that we've gone through this history lesson, exactly what's next? Well, we're now talking about what is called AGI, or artificial general intelligence. And this is machines that can perform any intellectual task that a human can. We're also talking about ethics and regulations. So how do we ensure AI is used responsibly? We're definitely talking about job disruption, because every other day somebody's making a video talking about how AI is going to take somebody's job or create new ones. And we're also talking about AI and creativity, meaning can AI truly create, or is it just remixing stuff? But regardless, the future is wide open and we're all just a part of it. But let's go ahead and wrap all of this up. So, what started as ancient dreams of mechanical beings has evolved into a tech revolution touching every part of our lives. AI isn't science fiction anymore. It's science fact. And understanding how we got here gives us the tools to navigate where we're going next. So whether you're studying AI, working with it, or just curious about the future, one thing is clear: the journey is just getting started. So let's keep learning, because the best AI stories have yet to be written. Now that we've gotten through all of that, let's see if you've been paying attention. So let's do some check on learning. So first question: what event is widely considered the birth of artificial intelligence as a field of study? Is it the Dartmouth Conference in 1956? Is it the invention of the World Wide Web? Is it Alan Turing's publication of Computing Machinery and Intelligence? Or is it IBM's Deep Blue defeating Gary Kasparov? And the correct answer is the Dartmouth Conference in 1956, which was organized by John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. This is considered the founding event of AI as a formal field. It was the first time researchers gathered specifically to discuss machines that can simulate intelligence. Next question: which AI milestone marked the first time a computer program defeated a reigning world champion in chess? Would this be Watson that was winning in the game show Jeopardy? Would this be AlphaGo defeating Lee Sedol? Would this be Deep Blue defeating Gary Kasparov? Or would this be Eliza mimicking human conversation? And the correct answer is this will be Deep Blue defeating Gary Kasparov. So in 1997, IBM's Deep Blue made history by defeating world chess champion Gary Kasparov. And this milestone showed that AI could outperform humans in complex strategic games with clear rules. And our final question: why was the development of the program ELIZA in the 1960s significant in AI history? Is it that it was the first AI to pass the Turing test? Is it pioneered natural language processing by mimicking human conversation? Is it beats humans at strategy games? Or is it discovered a new scientific law? And the correct answer is it pioneered natural language processing by mimicking human conversation. So ELIZA, this was developed by Joseph Weizenbaum in the mid-1960s, and it simulated a conversation by mimicking a Rogerian psychotherapist. And it was one of the first programs to showcase natural language processing, sparking public interest and debate around machine intelligence and emotional response to AI. You've heard the term AI tossed around everywhere. on social media and tech news, maybe even around your dinner table. AI helps you unlock your phone with a Face ID. It recommends the perfect next YouTube video for you, and it does a whole bunch of other stuff. But what if I told you that not all AI is created equal? In fact, there are three major categories or levels of artificial intelligence, and understanding them is a total game changer for seeing where we are now and where we might be headed. And these three categories are narrow AI, general AI, also known as AGI or artificial general intelligence. And then we have artificial superintelligence. Now, they may sound a bit sci fi, but don't worry. We're going to unpack each one, explore real life examples or the lack of them, and discuss what makes each stage unique. So let's go ahead and break all of this down. All right, so first up, we got to talk about what AI categories even mean. So when we talk about AI categories, we're basically talking about how capable the AI actually is. So think of it like leveling up in a video game. You have level one, which is called narrow AI. And this is basically AI that can do one thing very well. And we have level two, which is called general AI. And this is AI that can think and learn like a human. And then we have level three, which is called superintelligence. And this is AI that goes way beyond human intelligence. And each level represents a different phase in AI's evolution from where we are now to where we might be in the possible distant future. So let's start with the kind of AI that's already running the world today. All right, so let's start with narrow AI, and this is also known as weak AI. So narrow AI, this refers to artificial intelligence that is designed and trained for a specific task. It's super smart at one thing, but totally clueless about anything else. So you could think of narrow AI as the laser-focused intern in your office. That person is amazing at putting spreadsheets together, but don't ask them to plan your wedding or give you any type of life advice. And here are some real life examples of narrow AI. So if you use any modern technology lately, you've already interacted with narrow AI. And some examples you might recognize are Siri, Alexa, and Google Assistant. And they can set timers, play music, and answer trivia, but don't expect them to write a novel or solve climate change. You also have recommendation algorithms. So Netflix, Spotify, and YouTube, they use AI to guess what you might like based on your previous choices. There's facial recognition. So every time you unlock your phone with Face ID, that's narrow AI. And then we have self-driving cars, or at least today's versions. So most autonomous vehicles, they use narrow AI to identify objects, stay in lanes, and make decisions in real time, but they still struggle in complex, unpredictable situations. So here are some of the strengths of narrow AI. Well, the first strength is it is efficient. So it's fast, accurate, and often better than humans at repetitive tasks. There's the low cost labor factor. So it automates routine work in areas like customer service, manufacturing, and logistics. And it's also ubiquitous. So essentially it's everywhere from banking and healthcare to your smart refrigerator. But there are also some limitations on narrow AI. So the first one is there's a lack of understanding. It doesn't know what it's doing. It just follows patterns. It has no common sense, so it cannot generalize from one task to another, and it can be easily fooled. So small changes in data can throw it off. So in short, narrow AI is smart, but it's not wise. It's the world that we live in now, and it's already transforming industries. But as powerful as it is, narrow AI is just the tip of the iceberg. So if that's the case, then what's next? What's next is AGI, or Artificial General Intelligence. So AGI, and it's sometimes called strong AI, and this refers to machines that can perform any intellectual task that a human can do. That means it doesn't just follow instructions, but it can understand context, it can learn new skills on the fly, it can apply knowledge across different domains, it can think abstractly, and it can make judgments and adapt to new situations. So in other words, AGI will be like having a human mind inside of a machine. As far as examples of AGI are concerned, well, here's the thing. We don't have AGI just yet. There's no AI today that can match the full scope of human intelligence, but it is a hot topic in research and theory. And many tech companies like Google DeepMind, OpenAI, and Anthropic, they are actively working to bring this to fruition. So exactly how would AGI be different from narrow AI? So let's imagine you've got a narrow AI that can identify cats in pictures. Now that's great, but that's all it can do. It cannot explain why cats are so popular on the internet. It cannot tell you how to adopt one, and it cannot crack a cat joke. Now imagine you have an AGI system. You could ask it to analyze your cat's behavior, It can write a song about cats. It can learn how to take care of a kitten from scratch. And it can debate the ethics of pet ownership. AI essentially would not need to be trained separately for each task. It would just learn and adapt just like we do. So here are some of the key characteristics of AGI. The first one is it has human-like cognitive abilities. It can self-learn across multiple tasks. It has flexible problem-solving skills, and it also has contextual understanding. Now, here are some of the challenges that are associated with AGI. The first is consciousness and understanding. And basically, what we're saying is, how do we replicate human consciousness or self-awareness in code? Then there's common sense reasoning. So AI, it often lacks basic logic that humans take for granted. And then there's ethics and safety. So a machine that can think like a human also has the potential to do serious harm if misused. So now that we got all of that understood, this brings us to the final boss of AI, and that is called superintelligence. So artificial superintelligence, this is the hypothetical point at which AI far surpasses human intelligence in every way. We're talking about scientific creativity, general wisdom, social skills, emotional intelligence, you name it. It's not just as smart as a human, it's actually smarter. We're talking way smarter, like humans versus ants level smarter. Now, all of this sounds like science fiction, and for now, that is correct. ASI does not exist, but it's one of the most discussed and feared concepts in the AI community. Philosophers, futurists, and AI researchers, they debate what ASI would look like and whether it could be safe or even possible. So why do people worry about ASI? So when we think about ASI, we're thinking about machines that could solve problems we can't even comprehend. They could redesign their own code to become even more intelligent, and they can make autonomous decisions that shape economies, governments, and societies. So just imagine an AI that can cure cancer, eliminate poverty, and solve climate change. Now, all of that sounds great, correct? Now imagine that same AI deciding humans are inefficient and becomes hostile. Or this AI alters financial markets at a speed humans can't monitor, or it pursues goals that do not align with our survival. This is why folks like Elon Musk, Stephen Hawking, and Nick Bostrom have raised the alarm about AI safety and alignment. In fact, Nick Bostrom's book, which is titled Superintelligence, this is a deep and kind of terrifying dive into the risks associated with ASI. And some of the key traits of ASI that you need to keep in mind are the following. So one, it is exponentially smarter than humans. It is capable of self-improvement. It is potentially uncontrollable. And it also has unpredictable behavior. Now, if you want a quick summary that you can refer back to when discussing artificial intelligence versus artificial general intelligence versus artificial superintelligence, here's a little chart that I put together that you can use at your own leisure to comprehend all of this madness. All right, so exactly where are we right now? Well, we are firmly in the narrow AI era. So even advanced systems like ChatGPT, Midjourney, or Tesla's Autopilot are still narrow in scope. They can appear super smart in one domain, but they fall apart in others. AGI, this is the next big leap, but no one's cracked it just yet. It's the holy grail for many researchers, and some believe we might see it within the next few decades or even within the next few years. And others, they think it's a century or more away. When it comes to superintelligence, that's even further out if it ever happens. But that hasn't stopped us from imagining what that could possibly mean. All right, so let's go over some common misconceptions to watch out for. The first common misconception is AI is the same as AGI, and it's not quite true. Most AI that you interact with today is narrow AI. Now, just because it's impressive, that doesn't mean it's human level smart. Also, another misconception is ChatGPT is conscious. No, it's not. ChatGPT doesn't understand what it's saying. It's just really good at predicting what words come next. And then another misconception is superintelligence is just science fiction. Now, that's true today, but it's a serious topic in academic and policy circles. So preparing for it now, this could save a lot of headaches later. So now you need to ask yourself, why does any of this even matter? Well, knowing the differences between narrow AI, general AI, and superintelligence isn't just good trivia. This helps you think critically about the AI tools that you use every day. It helps you understand the risks and opportunities for future developments. It helps you navigate ethical discussions about AI governance and regulation. So whether you're a developer, a teacher, a policymaker, or just an interested human being, this knowledge can give you power. Now, with all of that being said, let's go ahead and wrap all this up. Artificial intelligence. This is one of the most fascinating and potentially world changing technologies we've ever created. Narrow AI is already transforming industries. General AI, this could redefine what it means to quote unquote think. And superintelligence, this could either solve our biggest problems or create new ones we can't even imagine. So each step up the ladder brings new possibilities and responsibilities. The question is, how will we choose to build and manage this intelligence? And essentially, that's what's at the heart of this AI fundamentals course. It's not just learning what AI is, but it's learning what kind of future do we want to build with it. Now let's get to the fun stuff. Check on learning. So the first question is, which of the following best describes narrow AI? Is it an AI system that surpasses human intelligence in all areas? Is it an AI system that is capable of general reasoning and understanding like a human? Is it an AI system designed to perform a specific task or limited range of tasks? Or is it a theoretical system that operates without needing data inputs? And the correct answer is it is an AI system designed to perform a specific task or a limited range of tasks. So narrow AI, which is also known as weak AI, is specialized in performing a single task like facial recognition or voice assistance. It does not possess consciousness or general intelligence. It's focused, efficient, and just task specific. Next question. General AI, also known as AGI, is fundamentally different from narrow AI because A, it doesn't require programming, B, it can operate on cloud platforms without user input, C, it only works in theoretical simulations, or D, it can learn and apply knowledge across a wide range of tasks. And the correct answer is it can learn and apply knowledge across a wide range of tasks. So general AI, this refers to machines that can understand, learn, and apply knowledge flexibly, just like a human. It's capable of reasoning, adapting, and solving unfamiliar problems, which, unlike narrow AI, is limited to specific tasks. And our final question, what is superintelligence in the context of artificial intelligence? Is it a type of AI that can only be used in military defense? Is it a hypothetical that exceeds human intelligence in every aspect? Is it an AI that can match human intelligence in specific industries? Or is it a supercomputer with unlimited processing power? And the correct answer is it is a hypothetical that exceeds human intelligence in every aspect. So superintelligence, this refers to an advanced form of AI that surpasses the smartest human minds in virtually every field. We're talking science, creativity, social intelligence, and much more. However, it is still theoretical, but it still raises many ethical and safety concerns. You've probably heard the phrase AI is everywhere more times than you can count. But what does that really mean? Are we just talking about robots and sci fi stuff, or is artificial intelligence actually impacting your everyday life? Well, here's a spoiler alert, it's actually doing it. From helping doctors diagnose diseases faster to making sure your Netflix suggestions are scarily accurate, AI is working behind the scenes across almost every industry, and it's only getting started. So in this video, we're going to take a guided tour through 4 major industries where AI is making waves: healthcare, finance, transportation, and entertainment. And by the end, you'll be able to recognize how AI is already transforming the world around you and why it's one of the most powerful technologies of our time. All right, so let's kick things off with an industry where AI can literally save lives, and that's healthcare. So let's talk about diagnosing diseases. AI is helping doctors detect diseases earlier and more accurately than ever before. When it comes to medical imaging, AI algorithms that can scan X-rays, MRIs, and CT scans to detect abnormalities like tumors, fractures, or infections, often spotting things human eyes might miss. An example of this will be Google's DeepMind, where they developed an AI that can identify over 50 eye diseases from retina scans. Then there's cancer detection. AI can analyze mammograms or biopsies and flag early signs of breast cancer or skin cancer. And studies show that in some cases, AI can outperform radiologists in accuracy. Then there's predictive analytics. So imagine knowing someone is at a high risk of a heart attack before it happens. AI can make that possible. Predictive models, they analyze patient history, genetics, lifestyle factors, and even wearable data to identify risks. In hospitals, they use these models to prevent complications, reduce readmissions, and deliver more proactive care. Another use case is virtual health assistants and chatbots. So, healthcare AI isn't just for doctors, it's helping patients as well. Chatbots, they can answer basic medical questions, schedule appointments, or remind patients to take their medications. Virtual assistants like Babylon Health or Ada, they use AI to offer symptom checks and medical advice. So, they're not replacing doctors, but they're making healthcare more accessible and less overwhelming. And then there's drug discovery and development. So finding new medicines is expensive and time consuming, and AI is flipping the script. AI can analyze massive data sets to predict which compounds might work against certain diseases, and it's also speeding up clinical trials by identifying suitable patient groups and potential side effects. And during the COVID-19 pandemic, AI helped researchers quickly model virus proteins and identify potential drug targets, and that was considered game changing. Now let's talk dollars and cents. The finance world has embraced AI in a big way, and it's reshaping how we bank, invest, and fight fraud. And speaking of fraud detection, AI, this is like a digital watchdog, keeping an eye out for suspicious behavior. Machine learning algorithms, they can analyze millions of transactions in real time to spot patterns and detect fraud. So if something looks off, like a huge withdrawal in a foreign country, AI can freeze the transaction and alert the user instantly. So there's no more waiting days to find out your credit card was compromised. Then there's personalized banking. So banks are using AI to deliver smarter, more personalized services. You have chatbots like Bank of America's Erica or Capital One's Eno, where they can check your balance, track spending, and answer questions 24/7. Also, AI-powered financial advisors, which are also called robo-advisors like Betterment and Wealthfront, they help you invest based on your goals and risk tolerance, so there is no human advisor that is required. Then there's credit scoring and loan approvals. So traditionally, lenders they use credit scores and income reports to decide who qualifies for a loan. But that system can be unfair or incomplete. AI models, they can look at alternative data like utility payments, education level, or even your online behavior to create a more accurate financial profile. And this can help underbanked populations get access to credit. And then there's stock market predictions and trading. So Wall Street has gone high tech. Hedge funds and investment firms, they use AI to analyze market data, news reports, and even social media sentiment to predict stock movements. And algorithmic trading bots, they can execute millions of trades in milliseconds, reacting faster than any human could. So essentially, just don't expect to beat them at their own game. All right, next let's talk about AI being used in transportation. So, transportation isn't just about planes, trains, and automobiles anymore. It's about smart systems that move people and goods more efficiently, and AI is driving the shift. So, the first one is autonomous vehicles. And this is the poster child of AI in transportation. Companies like Tesla, Waymo, and Cruise, they are using AI-powered sensors and cameras to navigate roads, avoid obstacles, and follow traffic laws. And AI processes data from LiDAR, GPS, radar, and cameras in real time to make driving decisions. Now, we're not at full autonomy just yet, but we are getting closer. And many cars, they already include lane keeping assistance, automatic braking, and adaptive cruise control. And then we have traffic management in smart cities. So if you ever sat in traffic and thought to yourself that there has to be a better way, well, guess what? AI agrees with you. Traffic lights and control systems in smart cities, they can adjust based on real-time traffic flow. And predictive analytics, they can help city planners understand traffic patterns and optimize road designs or construction schedules. Next, there's public transportation optimization. So AI, it helps buses, trains, and subways run more efficiently by predicting delays, managing fleet schedules, and providing real-time updates to passengers. Apps like Transit or Move It, they use AI to give commuters the fastest routes and alert them about service changes. And then there's logistics and delivery. So from Amazon packages to global supply chains, AI is streamlining delivery. AI-powered route optimization tools to help drivers avoid traffic and reduce delivery times. Robotics and drones, they're being used in warehouses and even last-mile deliveries. And companies like UPS, FedEx, and DHL, all of them use AI to manage logistics at scale, which saves money and reduces emissions. All right, so now for the fun stuff. You've probably interacted with AI and entertainment every single day without even realizing it. And one of the ways is through personalized recommendations. So let's be honest. How often do you scroll through Netflix, Spotify, or YouTube without even thinking? That's the magic of AI if you're doing that. because recommendation engines, they use AI to analyze your watch listen history, your likes, and your behavior. And based on that data, they suggest what to play next, and they get eerily good at it. And this isn't just convenience, this keeps users engaged much longer, which is gold for streaming platforms. Then there's content creation and curation. So, yes, AI is getting creative as well. AI tools like Dolly, Midjourney, and Runway, they can generate art, music, and even video from text prompts. And platforms that use AI to automatically tag, categorize, and edit content, which saves creators tons of time. In sports broadcasting, for example, AI can instantly identify highlight-worthy moments and generate clips in real time. Then there's video games. So AI has been a part of gaming for years, but now it's leveling up. Procedural generation, this uses AI to create endless maps or challenges. So think of Minecraft or No Man's Sky. Game AI, it can adapt to your playing style, making opponents smarter and gameplay more immersive. And tools like Unity, ML agents, they let developers train AI to learn game strategies over time. Then there's deepfakes and virtual influencers. So this is when we get to the weird and wild side of entertainment. So deepfake technology, this uses AI to manipulate video and audio, creating realistic fake videos of people saying or doing something they never did. And while this raises ethical concerns, it's also used in film production for dubbing, stunt doubles, and historical recreations. And then we have virtual influencers like Lil Miquela, and these are AI generated personas with millions of followers on Instagram. But as exciting as all of that might sound, they do blur the line between real and digital celebrity. All right, so let's not forget that AI is also reshaping other industries such as education, where personalized learning tools like Khan's Academy AI Tutor is implemented. You have AI chatbots for student support, and you have grading automation and plagiarism detection tools. It's also being used in agriculture, where AI drones, they can monitor crop health, they can automate irrigation systems, and they can use predictive analytics for weather and yield forecasting. You'll definitely find it being used in manufacturing with AI-powered robots on factory floors, predictive maintenance for equipment, and quality control through computer vision. It's also in retail, where you have AI chatbots and virtual assistants that can help you shop, inventory management and demand forecasting, and visual search, where you can say something like, show me shoes that look like this, and the image will pop up showing you shoes that look like that. Now, let's talk about some challenges and considerations. So, AI is powerful, but it's not perfect. With great tech comes great responsibility. So, here are a few challenges that we need to watch out for. The first is privacy concerns. So, AI, this relies on a lot of data. And that raises questions about how personal data is collected, who owns it, and how it's being used or misused. Then there's bias and fairness. AI systems, they can inherit biases from the data that they've been trained on, and this can lead to discriminatory load decisions, inaccurate medical diagnosis, and biased hiring algorithms. And then there's the big one everybody's concerned about, and that is job displacement. So AI is automating tasks that used to require human labor. That's efficient, but it also puts certain jobs at risk. At the same time, it's creating new roles in AI development, ethics, and data science. Now, to wrap all this up, from hospitals to Hollywood, AI is already woven into the fabric of modern life. It's not just a buzzword or a distant dream. It's here and it's doing everything from fighting fraud to creating digital pop stars. So, the key takeaway: AI isn't replacing us, it's transforming how we live, work, and create. And by understanding how AI is used across different industries, you're not just becoming a better student of AI, you're preparing to be a part of its next big leap. And that's what this AI Fundamentals course is all about. Not just understanding the technology, but recognizing its real world impact. All right, so let's do some check on learning to see if you've been paying attention. So the first question is, which of the following is a real world application of AI in the healthcare industry? Is it AI chatbots designing hospital blueprints? Is it machine learning algorithms predicting patient diagnoses? Is it AI creating workout plans for celebrities? Or is it virtual reality replacing physical surgery? And of course, the correct answer is machine learning algorithms predicting patient diagnoses. So in healthcare, AI is used for diagnostic purposes by analyzing large sets of patient data. Machine learning algorithms, they can detect patterns in lab results, medical images, and symptoms to assist doctors in diagnosing conditions like cancer, heart disease, and diabetes. Next question. How is AI most commonly used in the finance industry? Is it replacing human CEOs with AI agents? Is it powering voice assistants in ATMs? Is it detecting fraudulent transactions through pattern recognition? Or is it creating new cryptocurrencies automatically? And the correct answer is it is detecting fraudulent transactions through pattern recognition. So AI is widely used in finance to monitor transactions in real time and identify suspicious patterns that may indicate fraud. And these systems learn from past fraud cases and become better at spotting anomalies over time. And our final question: what is one of the ways AI is used in the entertainment industry? Is it writing government policies? Is it generating personalized content recommendations on streaming platforms? Is it designing movie theater seating arrangements? Or is it replacing all actors with robots? And the correct answer is it is generating personalized content recommendations on streaming platforms. So streaming services like Netflix and Spotify, they use AI to analyze user preferences and behavior. Based on this data, AI generates personalized recommendations, enhancing user engagement and satisfaction. All right, so you've been learning all about what AI is, what it can do, and how it's showing up in your daily life, from your social media feed to your phone's face unlock feature. And all that stuff sounds cool, right? But now it's time to ask a much deeper question. Just because we can build it, should we? So, artificial intelligence isn't just about algorithms, data, and cool tech. It's about decisions. And those decisions, whether made by humans or machines, they come with real world consequences. And that's why ethics in AI is such a big deal. We're not just talking about science fiction scenarios like killer robots or world domination. We're talking about issues happening right now, like AI making hiring decisions, predicting crime, or deciding who gets a loan. So let's dive in and talk about four of the most important ethical pillars in AI. That is bias, fairness, transparency, and accountability. Now, this isn't a lecture, it's just a real conversation about what's at stake in the AI powered world we're building together. Before we break down the big four, let's quickly cover why AI ethics is such a hot topic. Well, AI is already making or influencing decisions that affect who gets hired or fired, who gets approved for a mortgage or a loan, what news you see on your social media feed, whether you get stopped by police in a predictive policing system, or how your medical treatment is decided. Now, if those systems are flawed, biased, or lack oversight, then bad things can happen. And people can be unfairly treated, excluded, or even harmed. And the worst part, they might not even know why it's happening. So let's break down what's really going on behind the scenes. All right, so let's talk about bias in AI. So, biases in AI happen when an algorithm produces results that are systematically unfair or discriminatory. And this is often because of problems in the data it was trained on or how it was built. And here's the kicker: AI doesn't create biases on its own. It learns from data created by humans. So, if that data reflects real world inequalities or stereotypes, then guess what? The AI learns those as well. So here's a real world example. We have facial recognition. So facial recognition systems have repeatedly been found to perform worse on people with darker skin tones, especially Black women. Now, why is this? This is because the training data often included mostly white male faces, so the system wasn't as good at recognizing faces outside of that group. Now, that's just not a technical problem. It's a social and ethical problem with real consequences, like wrongful arrests or denial of services. And here are some other examples of biases. So you have hiring algorithms that are trained on resumes from past employees. If the company historically hired mostly men, the AI might quote unquote learn to prefer male candidates. There's also predictive policing systems that focus on areas with high crime reports, which are often over policed to begin with, creating a feedback loop of targeting certain communities. And then there's healthcare tools that predict patient risk but underrepresent symptoms and outcomes for women or minority groups. Now, what causes these AI biases? Well, the first one is biased training data. So basically, it's garbage in and garbage out. Then there's a lack of diversity in design teams. So homogenous groups, they may not anticipate real world impacts. And then there's inadequate testing and auditing. So if you don't do any checks, there's going to be hidden biases. Now, biases, this isn't just a bug. It's a mirror of our own societal flaws. And unless we actively address it, AI will just reinforce the same problems. All right, so next let's talk about fairness. So, what does fairness mean in AI? Well, fairness, this is about treating people equitably, ensuring that AI systems do not discriminate based on race, gender, age, disability, or other protected characteristics. And all that sounds simple, right? But in practice, fairness can get really complicated because what's fair isn't always black and white. So let's say you're building an AI to screen job candidates. You might ask questions like, should the AI ignore all demographic data like race and gender, or should it consider those factors to correct past imbalances? Now, there's a big difference between equality, which is treating everyone the same, and equity, which is giving people what they need to succeed. And then there's the types of fairness in AI. So here are a few ways researchers define fairness. So we have demographic parity. And this is ensuring equal outcomes across groups, such as hiring rates for men and women. Then there's equal opportunity. This is ensuring equal chances for success, regardless of background. Then there's individual fairness. So this is saying that similar individuals, they should receive similar outcomes. So now the question is, how come fairness is not easy? So let's say that you create an AI model that's 95% accurate overall. And all of that sounds great. But what if it's 99% accurate for men and 85% accurate for women? Is that fair? Well, not so much. That's why fairness is more than a math problem. It's a values problem. It requires conversations about what we're optimizing for and who gets prioritized. All right, so let's go ahead and talk about transparency. So, exactly what is this? So, AI can be complex, like extremely complex, especially with deep learning systems like neural networks. It's hard to explain exactly why a decision was made. And that's why many AI systems they are often called black boxes because inputs go in, a decision comes out, but no one, and not even the creators, fully understand what happened in between. And that's a problem, especially when the AI is deciding whether you qualify for a loan, how long your prison sentence should be, or whether your job application gets through the filter. So, exactly what does transparency actually look like? Well, transparency means making it clear on how AI systems work, what data it uses, and why it made a specific decision. So, think about it like this. If you are denied a loan, shouldn't you have the right to know why? And if an AI tool is being used in your workplace or your child's school, don't you deserve to understand what it's doing? So now let's talk about the challenge of explainability. So this is where the concept of explainable AI comes in. Explainable AI, this focuses on designing models that can justify their decisions in understandable terms, highlight which features were most important, and help humans interpret outcomes. So it's a trade-off. Some of the most accurate models, like deep neural networks, are also the hardest to explain. But if people are affected by the outcome, explainability is not optional, it is essential. All right, next let's talk about accountability. So, why does accountability matter? So, let's say an AI powered self driving car hits a pedestrian. Well, who's going to be responsible? Is it going to be the software developer, the car manufacturer, or the AI itself? And this question is at the core of accountability in AI, making sure someone is responsible when things go wrong. It is not just about physical harm. So think about an AI that wrongly denies unemployment benefits, or a chatbot that spreads hate speech, or a facial recognition system that gets someone arrested. In every case, someone needs to answer for it. Now, with accountability, this raises tough questions like, should AI systems be subject to the same laws as humans? And do we need new regulations for AI accountability? And also, what role do governments play in monitoring AI systems? In some countries and regions, like the European Union with its AI Act, they are starting to create legal frameworks to address these questions, but they're still in their early days. So here are some ways to build accountability. The first is through audit trails, and these are logs that show how and why decisions were made. Then there's the human in the loop system, and this is when a human reviews AI decisions before they're final. And then there's clear ownership. So organizations, they must take responsibility for the AI they deploy. Now, at the end of the day, accountability isn't about just blaming machines. It's about ensuring humans stay in charge of what AI does and does not do. So let's put all of this together. Ethical AI isn't just about better tech. It's about better choices. It means involving engineers and designers who build the systems, policymakers who set the rules, business leaders who decide how AI is used, and everyday users like you and me who are impacted by it. And ethics, it needs to be baked into AI from the very beginning, not slapped on like a band-aid at the very end. So, exactly what can you do about this? Now, you don't have to be a programmer or data scientist to care about AI ethics. In fact, that's the whole point. These decisions they affect everyone. So, here's how you can engage. First thing you can do is ask questions. Do not blindly trust AI systems. Be curious about how they work and what their data is being used for. Advocate for transparency. So, demand that the companies explain how their AI works. Promote diversity. Encourage inclusion in tech teams to reduce blind spots and improve fairness. Stay informed. So, read up on new developments in AI ethics from organizations like AI Now Institute, Algorithmic Justice League, and Partnership on AI. These are all great starting points. And then, most importantly, speak up. So, if you see unethical uses of AI in school, work, or your community, then go ahead and say something. Now, to wrap all of this up, AI is powerful, but with great power comes great responsibility. And as we build smarter machines, you need to ask yourselves, are they making the world better for everyone? Are they being used fairly and responsibly? And are we holding the right people accountable? The future of AI isn't just about faster processors or better algorithms. It's about values. It's about us deciding what kind of world we want to create, making sure the technology we build reflects that vision. Because at the end of the day, AI does not have a conscience. We do. And that's why AI ethics isn't a side topic, it is the topic. Now, with all that being said, let's do some check on learning. So, the first question is, so which of the following best describes algorithmic biases in the context of artificial intelligence? Is it AI systems that evolve over time based on user feedback? Is it errors in AI systems that result in consistently unfair outcomes for certain groups? Is it AI systems that require large data sets for training? Or is it AI systems that operate without human supervision? And the correct answer is it is errors in AI systems that result in consistently unfair outcomes for certain groups. So algorithmic biases, they occur when AI systems produce systematically prejudiced outcomes due to flawed data, design, or assumptions, often disproportionately affecting marginalized communities. Next question. Why is transparency important in the ethical development of AI systems? Is it helps users understand how decisions are made and promotes trust? Is it allows AI to outperform human intelligence? Is it enables systems to update automatically without oversight? Or is it ensures AI systems work faster and use fewer resources? And the correct answer is it helps users understand how decisions are made and promotes trust. So, transparency, this refers to the ability to understand and trace how AI models make decisions. And this clarity is essential to building public trust and ensuring accountability in the event of harm or error. And our final question, what role does accountability play in AI ethics? Is it allows AI systems to self regulate without human involvement? Is it assigns responsibility to developers or organizations for AI system outcomes? Is it increases the speed at which AI systems can operate? Or is it allows AI systems to learn from past decisions automatically? And the correct answer is it assigns responsibility to developers or organizations for AI system outcomes. So, accountability, this ensures that if an AI system causes harm or makes a poor decision, a responsible party like a developer, company, or a regulator can be identified and held answerable. Let's say you're trying to teach your dog a new trick, like how to fetch your slippers. You show her what to do, give her a treat when she does it right, and maybe offer a bit of encouragement when she doesn't quite nail it. That's called training. Now, what if I told you that teaching AI works a lot like training your dog? In the world of AI, we train machines using different types of learning methods. And the three big ones that you need to know are supervised learning, unsupervised learning, and reinforcement learning. And each one plays a unique role in how machines learn, adapt, and make decisions. And trust me, they're not as complicated as they sound. So let's go ahead and break all this down in plain English so that you have a thorough understanding of how all of this stuff works. First things first, why do we need learning models in AI? Now, before we dive into the differences, let's get one thing straight. Machine learning, which is a core part of AI, this is all about letting computers learn from data. So think of it this way. Instead of writing a specific set of rules for everything a computer should do, we let it learn patterns from data, just like we humans learn from experience. But how do we present that data to a machine? That's where these three learning methods come into play. All right, so let's start with the one that you're going to hear the most about, and this is called supervised learning. So, exactly what is it? Well, supervised learning, this is like going to school with a teacher guiding you every step of the way. You get the questions and the answers, and your job is to learn the pattern. In technical terms, you feed the algorithm a data set that includes input output pairs. The machine learns the relationship between them so that when it sees new input, it can predict the correct output. And here's an analogy to help you comprehend this. So let's say you're studying for a vocabulary test. On one side of the flashcard, it says feline. On the other side, it says cat. Now, over time, you learn that feline means cat. That's basically supervised learning in action. You're given the input, which is feline, and the correct output, which is cat, and you learn from that pairing. Now, here are some examples of supervised learning in action. The first one is email spam detection. So basically, you train a model on a labeled data set where the emails mark either spam or not spam. It learns the patterns and then it starts flagging future spam messages. Another example is loan default prediction. So you can feed a model a data set of customers, income, credit score, and a whole bunch of other stuff and label whether they repaid or defaulted. And then eventually the system's going to learn who's likely to repay. And then there's image classification. So you can show an AI thousands of images of dogs, cats, and birds, each labeled correctly. And then the AI will learn to classify new images based on what it has seen. Now, to make all of this happen, here are some common algorithms that are used in supervised learning. First is you have linear regression, you have what is called logistic regression, decision trees, support vector machines, and then you have neural networks that are used for labeled data. And the strengths of supervised learning is that it provides clear guidance with labeled data. There's high accuracy if this thing is trained well, and it's also easy to measure its performance. Its weaknesses, it requires a lot of labeled data, which can be expensive and time consuming, and it cannot handle unknown categories very well. All right, so let's talk about unsupervised learning. And this is the adventurous cousin of supervised learning. So, exactly what is it? Well, unsupervised learning is like being dropped into a new city with no map, no guide, and no idea where you're at. Your job is to explore and find patterns on your own. In AI terms, this means you give the machine a data set with no labels. The algorithm explores the data and tries to group or organize it based on similarities. And here's a real world analogy to help you comprehend this. So imagine that you inherit a giant box of clothing. There are no labels, no categories. You don't know what belongs where. So what do? Well, you might sort the clothing by color, by type, and by season. And basically, that's unsupervised learning in a nutshell. You're finding structure and patterns without being told what's right. And here are some examples of unsupervised learning. So you have customer segmentation. And this could be where businesses that use unsupervised learning to group customers by behavior, buying patterns, or demographics without predefined labels. There's what's called market basket analysis. And this is where retailers use it to find product combinations that are often bought together, like somebody going to buy some chips and soda. And then there's anomaly detection. And this is used to find unusual data points like fraudulent transactions in banking. And here are some common algorithms that are used in unsupervised learning. You have what is called k-means clustering, hierarchical clustering, principal component analysis, and autoencoders. And the strengths of unsupervised learning are as follows. So there is no need for labeled data. It's great for discovery and exploration, and is helpful in summarizing or simplifying complex data. However, its weaknesses are it's harder to evaluate performance because there are no correct labels, and the results can be less predictable and interpretable. All right, so last but definitely not least, we got to talk about reinforcement learning. And this is the most dynamic and fun of the bunch. So, exactly what is it? Well, reinforcement learning, this is like teaching a dog tricks using treats and timeouts. So, when the dog sits, you give it a reward. When it jumps on the couch, you scold it. And over time, the dog learns which actions lead to good outcomes. Now, in AI terms, an AI agent learns by interacting with an environment. It takes action, gets feedback, which is a reward or a penalty, and improves its strategy over time. And a real world analogy to help drive this home is imagine that you're playing Super Mario Brothers. Every time you beat a level, you get points or a reward. If you fall into a pit and you lose your life, you get penalized. And then eventually you learn which moves work and which ones don't, and eventually you get better. That's essentially reinforcement learning. And here are some examples of reinforcement learning. So we have self-driving cars, where they're learning how to navigate roads by trying actions and getting feedback. It's also used in robotics, where you can teach a robot to walk, grab objects, or complete complex tasks. It's used in game playing AIs. So you have DeepMind's AlphaGo and OpenAI's 5. They use reinforcement learning to master Go and Dota 2, beating world champions. And then you have dynamic pricing models, where some businesses they use reinforcement learning to adjust prices in real time based on demand and competition. And when it comes to reinforcement learning, here are the key concepts. So the first one is called an agent. That is the decision maker, or basically the AI. Then there's the environment, and this is the world the agent interacts with. There's the action. This is what the agent chooses to do. There's the reward. This is the feedback based on the action. There's the policy. This is the agent strategy. And then there's what's called the episode. And this is a sequence of actions and rewards. And here are some common algorithms that are used with reinforcement learning. You have Q learning, deep Q networks, policy gradient methods, and actor-critic models. The strengths of reinforcement learning are as follows. So it is great for learning sequences of decisions. It excels in dynamic environments, and it learns optimal strategies through experience. Its weaknesses are it can take a long time to train. It requires a lot of interactions with the environment, and it can be unstable or sensitive to reward design. Now, here's a chart that I put together to kind of sum things up side by side when it comes to supervised learning versus unsupervised learning versus reinforcement learning. So take a screenshot and get that in your life if this will help you understand this stuff much better. Now, just in case you're still not sure which one is which, let me go ahead and break this down again. When it comes to supervised learning, you can think of it like a bank that wants to predict if a customer will repay a loan based on income, credit score, and age. When it comes to unsupervised learning, you can think of it like a retailer who wants to group customers by purchasing behavior without knowing anything about them. And when it comes to reinforcement learning, you can think of it as a robot that's learning to walk by falling, getting back up, and being rewarded when it takes successful steps. Now, when it comes to all of these methods, can these learning types work together? Well, the answer is absolutely. In fact, many real-world AI systems, they combine techniques. The first one is called semi-supervised learning, and this uses a mix of labeled and unlabeled data. Then you have self-supervised learning, and this is a hot trend where AI creates its own labels from raw data, and this is used in models like GPT. And then you have reinforcement plus deep learning. This is also known as deep reinforcement learning, and this combination powers many cutting-edge systems like AlphaGo. So while these categories are helpful for understanding, the lines are starting to blur as AI evolves. So now that leads us to this next question. Why does any of this even matter? So if you're stepping into the world of AI, this knowledge isn't just nice to have, it's foundational. This knowledge helps you build smarter AI systems. It helps you choose the right tools for the job. It helps explain AI to non-technical people, and it helps you understand the strengths, limitations, and risks of each method. So whether you're training a chatbot, analyzing market trends, or building the next killer AI application, knowing how these machines learn, this can give you a serious competitive edge. Now let's go ahead and wrap all this up. So here's the big picture. Supervised learning. This is like solving a puzzle with the picture on the box. Unsupervised learning is like solving a mystery without knowing what you're looking for. And reinforcement learning, this is like leveling up in a game through one win or one failure at a time. Now, each method has its strengths, each fits a different kind of problem, and together they make up the toolkit that's powering everything from your phone's voice assistant to the future of autonomous robots. And the more you understand these learning styles, the more you'll see their fingerprints all over the tech world. And who knows, maybe the next breakthrough in AI will come from you. Now, with all of that being said, let's do some check on learning. So our first question is, which of the following best describes supervised learning? Is it the model learns from data that contains no labels or outcomes? Is it the model learns by receiving rewards or penalties for actions? Is it the model is pre-programmed with fixed rules and does not adapt? Or is it the model learns from labeled data to make predictions or classifications? And the correct answer is the model learns from labeled data to make predictions or classifications. So in supervised learning, the model is trained using a data set that includes both input features and corresponding correct outputs known as labels. It learns to map inputs to outputs, which make it suitable for tasks like classification when it comes to spam detection and regression when it comes to predicting housing prices. Next question. What is a key characteristic of unsupervised learning? Is it requires large amounts of labeled data? It uses feedback to learn optimal behavior over time. It discovers hidden patterns or structures in unlabeled data, or it relies on predefined categories for sorting data. And the correct answer is it discovers hidden patterns or structures in unlabeled data. So, unsupervised learning does not rely on labeled outputs. Instead, it explores the data to find natural groupings or structures, like clustering customers based on purchasing behavior or reducing dimensionality using principal component analysis. And our final question in reinforcement learning, what guides the learning process? Is it feedback in the form of rewards or penalties based on actions taken? Is it labeled data sets? Is it hidden patterns in data? Or is it pre-assigned categories? And the correct answer is it is feedback in the form of rewards or penalties based on actions taken. So reinforcement learning is all about learning through interaction. An agent learns to make decisions by performing actions in an environment and receiving feedback in the form of rewards or penalties, refining its strategy over time to maximize cumulative reward. Let's say you're scrolling through your favorite streaming app. You watched a few rom-coms last week, and suddenly it's suggesting a dozen more. Now, is this magic? Not exactly. That's machine learning doing its thing behind the scenes. But how does it actually work? Well, this is going to be your deep dive into the structure of machine learning models, which are the inner workings that power everything from recommendation engines and facial recognition to language translation and self-driving cars. In this video, we're going to break it down step by step. We're going to talk about what features and labels are and why they matter, what training data is and how models learn from it, and then how we evaluate if a model is actually doing its job. So I'm going to try to make this as pain-free and practical as possible. So with that being said, let's get into it. All right, so first things first, we need to identify exactly what is a machine learning model. So imagine you're trying to teach a dog new tricks. You give it a command like sit, you show it how to sit, you give it a treat when it gets it right, and then after enough repetition, the dog learns what sit actually means. A machine learning model is a little like that dog, but instead of learning tricks, it's learning patterns from data. You give it a bunch of examples, which are called training data. You tell it what the correct answers are, which are known as labels, and it adjusts itself internally to get better over time. Eventually, it can make predictions or decisions based on new data it hasn't even seen before. Now, with that being said, let's go ahead and explore each part of the process in more detail. All right, so first up, let's talk about features. Now, you could think of features as the information you give to the machine learning model to help it make a decision. It's like the ingredients in a recipe. Without them, the model can't cook up any results. And here are some examples of features. So let's say you want to build a model that predicts the price of a house. Here are some features that you might use. You could use square footage, how many bedrooms does it have, the number of bathrooms, the zip code, and the year the house was built, in addition to how big is the lot size. Now, each of these things is a feature or a data point that helps the model understand what might influence the house price. And when it comes to features, here are some feature types. So features, they could be numerical, like age, income, or temperature. They could be categorical, like color, gender, or zip code. They can be in Boolean, where they represent a true or false, or a yes or a no. Or they could be textual, like reviews or comments, where a comment might say something like special handling. Now, as a pro tip, choosing the right features, which is called feature engineering, this is one of the most important skills in machine learning because bad features can produce a bad model. All right, next let's talk about labels. So if features are the ingredients, then labels are the final dish you're trying to make. In machine learning, a label is the value or category you want the model to predict. So here's some examples of labels. So using our house price example, the label is the actual sales price of the house. Also, another example, if you're training a model to recognize spam emails, the label might be spam or not spam. And another example could be if you're training a model to recognize cats in images, the label is either a cat or not a cat. And then we have what is called supervised learning, and this is features plus labels. So most machine learning models, especially in beginner level projects, they use something called supervised learning, where the model learns from both the features and the correct answers or the labels. Now, the idea is simple. You show the model examples and the correct labels, and it will learn to predict the labels from the features. All right, so let's talk about training data. So you've got the features or the input and your labels, which are the output. Now you need to connect the dots, and that's where the training data comes in. So, exactly what is training data? Well, training data, this is the collection of examples the model uses to learn patterns. And each example includes both features and a label. So let's go back to the house price example. Your training data might look like this chart on your screen right here. And in this chart, the model analyzes these examples and learns how the input features relate to the output price. And over time, the model updates its internal math, which is called weights and biases, to improve its predictions. So remember in this example, square feet, bedrooms, bathrooms, and zip code, all of these are features. Your label is the price. So all of these features are going to help determine what the actual price of each house is. All right, so next let's talk about testing and evaluation. So your model has been trained. Now what do? Well, you need to evaluate it. Basically, you're testing how well it performs on new and unseen data. Now, why are you doing this? Because we don't want a model that just memorizes the training data. We want one that generalizes to new examples. And how do you do this? Well, the first thing you're going to do what is called splitting your data. Now, most machine learning workflows, they involve splitting your data set into training sets, and that's usually about 70 to 80% of the data, and this is used for training the model. And then the other 20 to 30% is called the testing set, and this is used for evaluating performance. Now, sometimes there's also a validation set, and this is used to fine-tune settings before the final test. Then after you do that, you're going to make predictions on the test set. So now the model makes predictions using the features in the test set. Then we compare those predictions with the actual labels in the test set. And then we use evaluation metrics. So basically, how do we measure whether the model is good? Now, this depends on the kind of task you're doing. And we're going to go ahead and explore some of those common types. All right, so let's talk about evaluation methods in machine learning. And the first type we're going to talk about are for classification problems. And you can use this for spam and not spam type of examples. And your common metrics include the following. You have accuracy, and this is the percentage of correct predictions. This is simple and intuitive, but it's not always reliable, especially for imbalanced data. Then we have what is called precision. So of all the positive predictions that the model made, how many of them were correct? Now, this is good when false positives are costly, like predicting diseases. Another metric is called recall. So, out of all of the actual positives, how many did the model find? Now, this is important when missing a positive is dangerous, like detecting fraud. Then we have what is called the F1 score, and this is the harmonic mean of precision and recall. Essentially, this balances the two, and this is great when you need an overall performance metric. And then we have what is called a confusion matrix. And this is a table that shows true positives, true negatives, and false negatives. Essentially, this gives a deeper look into how the model performs. And then we have some other types of evaluation metrics that are known as regression problems, and these are good for predicting house prices. So essentially, you're predicting a number instead of a category. And the first type is called the mean absolute error. And this is an average of how far off predictions are from actual values. You have what is called the mean squared error. And this is like the first one, but this squares the errors before averaging. And this essentially penalizes large errors even more. And then we have what is called the root mean squared error. So this is just like the square root of MSE, but this puts the error back into the original unit, like if we're dealing with dollars. And then you have the R squared score, or the coefficient of determination. And this measures how well the model explains the variability of the target. And a score of 1.0, this means a perfect prediction. Now understand, I'm just giving you a high level overview of what this stuff is. We're not going to go into extreme detail with this. Now, let's go ahead and tie all of this together with a real world analogy. And that analogy is going to be teaching a child to read. So, step one, as it relates to features, this is when you show the kid flashcards with letters on them, and the letters are the features. Then we have labels. This is where you also tell the kid what each word is supposed to sound like. And once again, these are the labels. Then we have training. So, this is when you go through hundreds of flashcards together. That is your training data. Then we have the evaluation. So later, you test the kid with new flashcards to see if they can still read correctly. You evaluate how many they got right, how fast, and whether they struggled with certain letters. These are the evaluation metrics. And basically, that is machine learning in a nutshell. All right, so congratulations. You now understand the basic structure of machine learning models. This isn't just geeky knowledge for coders or data scientists. It's foundational for anyone who wants to understand how AI works, make better use of smart tools, or even pursue a career in machine learning. So, whether you're trying to build your first model, you're trying to understand how AI makes decisions, or you just want to explain this stuff to other people, this knowledge gives you the power to do that. Now, just remember, AI models, they are only as good as the data that we give them and the way we measure their success. Now, with great data and great responsibility, we can build systems that really do make life a whole lot better. Now let's move on to our favorite section, and that is the check on learning. So our first question is, what are the features in a machine learning model? Is it the final outputs a model predicts after training? Is it the columns of data that represent input variables that are used to make predictions? Is it the labels that are assigned to each data point? Or is it the functions that are used to train the model? And the correct answer is it is the columns of data that represent input variables that are used to make predictions. So features are the individual measurable properties or characteristics of the data being used to train the model. In a spreadsheet analogy, they're the columns that describe aspects of each row or data point, like age, height, income, etc. Next question. Which of the following best describes labels in supervised machine learning? Is it data points that are used only during testing? Is it human assigned tags for model explainability? Is it functions that adjust the model's parameters? Or is it known outputs that correspond to input features and are used to train the model? And the correct answer is it is known outputs that correspond to input features and are used to train the model. So labels are the correct answers the model tries to predict during supervised learning. So for example, if you're building a model to predict whether an email is spam or not, spam and not spam are the labels. And our final question, which method is commonly used to evaluate the performance of a machine learning model? Is it training the model on new unseen data? Is it measuring the number of features in the data set? Is it splitting the data into training and test sets and using metrics like accuracy or precision? Or is it counting how many labels were assigned manually? And the correct answer is it is splitting the data into training and test sets and using metrics like accuracy or precision. So, to evaluate a model's performance, data is typically split into training and test sets. After training, the model is tested on the unseen data, and metrics like accuracy, precision, recall, and the F1 score are calculated to determine how well the model performs. Let's say you just trained a fancy new AI model. Maybe it's a spam detector, a medical diagnostic tool, or a system that predicts which customers are likely to cancel their subscriptions. You spend hours fine tuning the algorithm and feeding your data. Now you're staring at a number on your screen like 93% accuracy. Well, that sounds impressive, right? Well, maybe. So here's the catch, that number doesn't tell the whole story. Evaluating an AI model isn't as simple as checking a single score. To really understand how well a model is doing and where it might be failing, you need to dig deeper into a few key metrics such as accuracy, precision, recall, the F1 score, and the confusion matrix. So in this video, I'm going to unpack each of these metrics in plain English. You don't need any type of mathematics degrees to understand this. This is just going to be real talk with relatable examples. So let's go ahead and get into it. All right, so the first thing we need to figure out is exactly why do metrics matter? So imagine you're building a robot dog that's supposed to bark every time someone tries to break into your house. You test it and it barks every time the mailman comes, but not when a burglar actually sneaks in. Technically, the robot is working, but it's doing the wrong thing really well. And this is why performance metrics matter. They help us figure out, is the model making the right predictions? How often is it wrong? What kind of mistakes it's making? And is it balanced or biased? So let's go ahead and break down these tools that you can use to evaluate a model to make sure it's doing what it's supposed to do. Before we get into specific metrics, let's start with the confusion matrix because it's the foundation for understanding everything else. So, exactly what is this thing? Well, the confusion matrix, this is a table that shows how many times your model made correct and incorrect predictions. It's especially useful for binary classifications like yes or no predictions. So let's say that you're building a spam filter. You feed it a bunch of emails and it classifies each as either spam or not spam. Well, here's what a confusion matrix actually looks like right here on your screen. So let's go ahead and define these terms in simple language. So you have what is called a true positive. Now, as this relates to spam, that means that this is spam that was correctly labeled as spam. You have what is called a true negative. This is legit email that was correctly labeled as not spam. You have what is called a false positive. This is a legit email that got wrongly flagged as spam. Then you have what's called a false negative. This is spam that the model missed and labeled as not spam. So these four values, they help you calculate every other metric that we're going to talk about. All right, so our first metric is called accuracy. So accuracy, this is the simplest and most well-known metric. It tells you how often your model got things right. And as you can see on your screen right there, the formula is accuracy equals all of that stuff that comes after it. But in plain English, this simply states out of all the predictions that your model made, what percentage were correct? So here's an example of how this works. Let's say that your model analyzed 100 emails and 90 of those emails were correctly predicted, where it stated 80 of them were not spam and 10 were spam. And then it stated 10 of them were incorrectly predicted. Well, based on those numbers, you would have an accuracy rate of 90%. Now, when exactly is this useful? So accuracy is great when your data is balanced, meaning you have roughly equal amounts of both classes, like spam and not spam. Now, when is it misleading? Well, let's say only 5% of emails in your data set are spam. If your model predicts not spam for every email, it'll be right 95% of the time, but it's useless at catching spam. So the moral of the story is accuracy alone does not always tell the truth. All right, our next metric is precision. So precision, this tells you how many of the positive predictions were actually correct. And as you can see, there's the formula on your screen right there. And basically what this formula is saying is that of all the times the model said that this is spam, how often was it right? So here's an example to help drive it home. Let's say your model says 15 emails are spam. 10 are actually spam, which would be a true positive. And then 5 are legit emails that got flagged wrongly. That'll be a false positive. So your precision, once you do the calculations, that'll get you 67%. So why does this matter? Well, precision is super important when false positives are a big problem. So to put this into another example, let's think about medical diagnosis. So let's say an AI predicts whether someone has cancer. A false positive, this can cause anxiety, extra tests, and unnecessary treatment. Precision, this helps you minimize those false alarms. So if your goal is to avoid crying wolf, then focus on precision. Our next metric is called recall. So exactly what is this? Well, recall, which is also known as sensitivity or true positive rate, this tells you how many of the actual positive cases your model caught. So once again, you can see the formula on the screen, and to put that in plain English, that basically states out of all the spam emails that exist, how many did your model find? So here's an example. You have 20 emails that are actually spam. Your model correctly identifies 15 of them. That will be a true positive. However, it misses 5. That'll be a false negative. So if you do the formula, you would have a recall of 75%. So why does this matter? Well, recall is crucial when missing a positive case is dangerous. So let's put that into a real world application like fraud detection. So if a fraud detection system misses fraudulent activity or false negatives, that's money out of the door. You want to catch every shady transaction, even if you occasionally flag a legit one. So if your goal is to catch every possible true case, even if you get a few wrong, then you want to focus on recall. And then we have our fourth metric, which is called the F1 score. And this is the harmonic mean of precision and recall. It balances the two, especially when you want a single number to judge overall performance. So on your screen, you can see the formula. And basically, you could think of this as a referee between precision and recall. So here's an example. Let's say your model has a precision of 0.08, and then you have a recall of 0.06. Then once you do the calculations, your F1 score come out to be 68.5%. So exactly why does this matter? Well, the F1 score, this is a great all-around metric when your data is imbalanced and you care about precision and recall, and you need a single number to compare models. So if you're building something like a resume filter or a content moderation system, the F1 scores, they help you tune that balance. And right here on your screen is a quick cheat sheet explaining each metric and the different purposes that they serve. So if you find yourself in the business of building AI models, you want to pick the best one depending upon the type of problem that you're trying to solve. All right, so let's go over a real life scenario, and we're going to go back to our email spam filter example. So let's say you run a model on 1,000 emails, and out of the 1,000 emails, you have 700 legit emails are not spam, and then you have 300 spam emails. And when it comes to your model predictions, your model predicted 250 spam emails that were correctly flagged. That'll be a true positive. It also predicted 50 spam emails that were missed. That will be a false negative. It also predicted 100 legit emails that were incorrectly flagged as spam. That'll be a false positive. And then you have 600 legit emails that were correctly identified. That will be a true negative. And once you go through and do all of your calculations, you'll see that your accuracy rate was 85%, your precision rate was 71.4%, your recall rate was 83.3%, and your F1 score was 76.8%. So basically, when it comes to all of this, you get a full performance picture and not just a flashy 85% accuracy headline that you could use to sell your email spam filter product. All right, so let's go ahead and wrap all this up. So AI models, they can be flashy, but if you don't know how to evaluate them, then you're flying blind. So here's a quick takeaway checklist. A confusion matrix. This is where you want to start because you'll be understanding how many predictions are true or false or positive and negative. You have accuracy. This is good for balanced data sets, but you don't want to trust it blindly. You have precision. This is best when false positives are costly or dangerous. You have recall, and the focus here is when missing true cases is the worst case scenario. And then you have what is called the F1 score, and this is the go-to metric when you need balance. So remember, no single metric tells the whole story. You want to use them together to get a clear, honest picture of how your model is really performing. Now that we've got through all that, let's do some check on learning. So our first question is, which metric is the most useful when dealing with a class imbalance problem, such as you having many more negatives than positives? Would this be accuracy, precision, recall, or the F1 score? And the correct answer is this will be an F1 score. So accuracy, this could be misleading with imbalanced data sets because a model could predict the majority class and still achieve high accuracy. Precision and recall, they focus on different aspects of performance, but F1 score balances both precision and recall, making it a better metric for imbalanced data sets. Next question. A spam detection model identifies 80 spam emails correctly, but falsely marks 20 legitimate emails as spam. Which metric measures how well the model avoided labeling legitimate emails as spam? Would this be recall, accuracy, precision, or the F1 score? And the correct answer is this would be precision. So precision, this measures the proportion of true positives or correctly identified spam emails out of all predicted positives or emails that are labeled as spam. It tells us how many of the emails marked as spam are actually spam, which is critical when minimizing false positives like legitimate emails that are wrongly classified as spam. And our final question, what does the true negative value in a confusion matrix represent? Is it the model correctly predicted the positive class? Is it the model incorrectly predicted the positive class? Is it the model correctly predicted the negative class? Or is it the model incorrectly predicted the negative class? And the correct answer is the model correctly predicted the negative class. So in a confusion matrix, a true negative is when the model correctly identifies a negative class as negative. So for example, it correctly recognizes that a normal email is not spam. All right, so You started diving into the world of machine learning and everything seems kind of magical, I guess you can say. You feed a computer a bunch of data and boom, it can detect spam, predict the weather, or recommend your next favorite movie. But here's the reality check. Machine learning is not magic. It's math, data, and a whole lot of problem solving. And like any powerful tool, it comes with its own set of challenges. And three of the most common and most important ones that you're going to come across are called overfitting, underfitting, and data bias. And these issues, they can make or break your machine learning model. In fact, even if you're using the fanciest algorithms and state of the art hardware, your model will fall flat if you don't understand and manage these challenges. So, with that being said, we're going to go ahead and talk about these challenges one by one. Now, before we dive into the problems, let's remind ourselves what machine learning models actually do. So imagine you're trying to teach a machine how to predict house prices. You give it a bunch of examples like square footage, the number of bedrooms, location, and what those houses sold for. The goal is for the model to find patterns and learn the relationship between features, also known as input, and prices, which are also known as output. But here's the kicker. The model doesn't really understand houses or money. It just crunches numbers and finds patterns. And sometimes it finds patterns too well, and other times it doesn't find any meaningful pattern at all. That's where overfitting and underfitting come into play. Exactly what is overfitting? So, overfitting, this happens when your machine learning model learns the training data too well, like obsessively well. It memorizes every tiny detail, even the random noise or errors in the data. It becomes a straight A student on the training data, but completely bombs the test when it comes to new or unseen data. So imagine this. You're studying for a history test by memorizing every single word from the textbook. Then on the test, the questions are phrased differently, and you have no clue what to do. That's overfitting in a nutshell. And here are some signs that your model is overfitting. If you have high accuracy on training data, if it has a terrible performance on test or validation data, or it's a very complex model with too many parameters or too deep a neural network. So here's a real life example to make all this make sense. So let's say you're building a model to identify spam emails. You train it on thousands of messages, but your data set includes a weird pattern. Some spam messages are always sent at 3 o'clock in the morning. So your model learns that if it's 3 a.m., then it must be spam. Now, what's the problem? In the real world, lots of legit emails are sent at 3 in the morning, but your model has been trained on noise and not real patterns. So here's how to avoid overfitting. So the first thing is you can use more data. So get a larger, more diverse data set, which can dilute the noise. You can apply what is called regularization. So techniques like L1 and L2 regularization, this helps prevent the model from going overboard. You can do what is called cross-validation. This is where you train your model on different subsets of the data to ensure generalization. Then there's early stopping. This is when you stop training when performance on validation data stops improving. Then you can prune the model where you can reduce the complexity, where you have fewer layers or features. All right, next let's talk about underfitting. So underfitting, this is the opposite of overfitting. This is when your model is too simple to learn the underlying patterns in the data. It's like trying to use a single crayon to draw a realistic portrait. No matter how hard you try, you just can't capture the details. And your model basically performs poorly on both training and test data because it hasn't learned enough. And here are some signs of underfitting. So if you have low accuracy on both training and testing data, or you have very simple models like linear models when relationships are nonlinear, or your model cannot capture the trends or patterns. And here's a real life example of underfitting. So let's say you're trying to predict house prices again, but you build a model that only looks at square footage and ignores all other variables like location, the number of bathrooms, etc. The model might draw a straight line through the data when you actually need a curve to reflect market trends. That's underfitting. Basically, your model's just too basic to get the job done. So here's how you can fix underfitting. So you can use a more complex model. You can try decision trees, ensemble methods, or deep learning. You can add more relevant features where you can include other useful data like neighborhood crime rates, school ratings, etc. You can train the model longer. So sometimes underfitting happens when the model hasn't had enough time to learn. And you can reduce bias by making sure that your model isn't overly constrained by assumptions like linearity. Now let's try to make all of this make sense real quick. When it comes to underfitting, what you're going to get is a straight line that is trying to fit a curvy set of points, yet it misses the mark entirely. Now, if you want a good fit, this is when you have a smooth curve that flows nicely through the data. And when it comes to overfitting, you're going to get a crazy zigzag line that hits every point perfectly, even the weird outliers. Now, the one that you want is the middle one, because that is the one that accurately represents the data the best. Now, let's talk about balance. So, at the heart of overfitting and underfitting is something called the bias variance trade off. So, basically, high bias, this equals underfitting, where the model is too simplistic. High variance, this equals overfitting, where the model is too sensitive to noise. Now, the goal is to find a sweet spot with low bias and low variance, which leads to good generalization. So, think of it like a tightrope walk. You go too far in either direction, and your model will topple. All right, so next let's talk about data bias. So exactly what is this? Well, data bias, this happens when the data used to train your machine learning model isn't representative of the real world, where it could be skewed, incomplete, discriminatory, or just simply outdated. This means your model will make predictions that are inaccurate, unfair, or even harmful. And bias in data, this can lead to bias in decisions. And when machine learning is used in areas like hiring, healthcare, or criminal justice, the consequences can be serious. And here are some types of data bias. The first one is called sampling bias. This is when your training data doesn't reflect the diversity of the actual population. So for example, if you train a facial recognition model on mostly white male faces, it will struggle to identify women and people of color. You have what is called a label bias. And this is when the labels used for training are flawed or subjective. So an example of this would be in hiring. Resumes from women might have been historically rated lower, which the model then learns as a pattern. Then we have what is called measurement bias. And this is when features are measured inaccurately or inconsistently. So an example of this will be using zip codes as a proxy for income that can be misleading and discriminatory. Then you have what is called confirmation bias. And this is when data confirms a preconceived notion or hypothesis and ignores contradictory evidence. An example of this will be only including data that supports your prediction that older people don't use smartphones, when in fact many of them do. Now that leads us to our next question. Exactly why does data bias matter? Well, because machine learning does not have morals. It just mirrors the data that we give it. So if your data is biased, your AI will make biased decisions. It doesn't mean the algorithm is evil. It means the input is flawed. So always remember, when it comes to building machine models, you have a saying called garbage in and garbage out. Now let's go over some real world examples of bias in AI. Let's talk about Amazon's hiring tool. So Amazon, they built an AI to help with hiring, but it was trained on resumes that were submitted over 10 years ago, mostly from men. The AI then began penalizing resumes that included the word women, like women's chess club captain. Another example is facial recognition fails. So studies have shown that facial recognition systems have higher error rates for people of color, especially Black women. Now, why is this? Well, this is because the training data wasn't diverse enough. And another example would be predictive policing. So some law enforcement tools, they use crime data to predict where crimes might happen. But if the data reflects historical over-policing in certain neighborhoods, the AI then ends up reinforcing those patterns. So that leads us to, how can you detect and mitigate bias? Well, the first thing you can do is you can audit your data. So you can ask questions like who's represented and who's missing. You can also diversify your training set, where you can include a wide range of ages, races, genders, and other groups. You can test fairness metrics, so you can evaluate model outcomes across different demographic groups. You can involve domain experts like ethicists, sociologists, and community leaders, where they can provide insights algorithms cannot. And most importantly, you can just be transparent, so you can share your data sources and model assumptions. Now, exactly what should you take away from all of this? Well, machine learning isn't just about building cool models. It's about building reliable, fair, and useful ones. That means understanding that overfitting isn't a flex, it's a flaw. Underfitting means your model is basically guessing, and data bias is the hidden enemy of fairness and accuracy. So getting your model to work in the lab is one thing. Making it work in the real world, where things are messy, diverse, and unpredictable, well, that's where the real skill lies. So let's go ahead and wrap all this up. So here's the deal. Building machine learning models is exciting, but it comes with big responsibility. Your models, they can influence people's lives, reinforce or break stereotypes, and shape decisions. So don't just aim for accuracy, aim for awareness. Be curious about your data, question your model's assumptions, and think beyond the numbers. Because in the end, the smartest machine learning practitioners aren't just those who can code. They're the ones who care about what the code actually does. Now, with all that being said, let's do some check on learning. So our first question is, what is the main characteristic of an overfitted machine learning model? Is it performs well on new and unseen data? It has a low training error but high validation error. It can capture patterns in the training data, or it has poor performance on both training and testing data. And the correct answer is it has a low training error but a high validation error. So overfitting happens when a model learns the training data too well, including its noise and outliers, which leads to low training error but poor generalization to new data. And this results in a high validation or test error. Next question. Which of the following best describes underfitting in a machine learning model? Is it the model has memorized the training data perfectly? Is it the model is too simple to capture the underlying patterns in the data? Is it the model has a complex architecture with too many parameters? Or is it the model is biased towards the test data? And the correct answer is the model is too simple to capture the underlying patterns in the data. So underfitting, this occurs when a model is too basic or rigid to learn the structure of the training data, which can lead to poor performance on both training and test data. It usually results from a model with insufficient complexity. And our final question is, data bias in machine learning can lead to what? Faster training times, improved model accuracy, fair and balanced predictions, or discrimination against certain groups or inaccurate predictions? And of course, the answer is discrimination against certain groups or inaccurate predictions. So data bias occurs when the training data does not fairly represent the real world scenario. This can cause models to make unfair or inaccurate predictions, especially for underrepresented groups or scenarios not present in the data. All right, so let's be real. When you hear the words machine learning algorithms, you might picture some super complicated code, a chalkboard full of math formulas, or a robot plotting world domination. But here's the thing. Machine learning algorithms don't have to be scary. In fact, they're more like tools in the toolbox. And once you understand what each one does, when to use it, and how it works, at least at a basic level, you'll realize they're actually pretty intuitive. So in this video, I'm going to break down some of the most popular machine learning algorithms in an easy to understand way. And these are the ones that show up pretty much everywhere, from textbooks to real world applications and interview questions. So by the end of this, you'll not only recognize them, but you'll know what problems that they're good at solving. So let's proceed. All right, so before we dive in, let's go ahead and set the stage. A machine learning algorithm, this is basically a set of rules or methods that a computer uses to learn from data and make predictions or decisions without being explicitly programmed for that specific task. So it's kind of like a chef following a recipe. Each algorithm has its own cooking style and preferred ingredients, which are your types of data. Now, some are better for finding patterns and others are great at predicting outcomes. And some are just lightning fast at sorting through chaos. So let's go ahead and talk about some of these various machine learning algorithms. All right, so the first one we're going to talk about is called linear regression. And this is all about predicting a number. It tries to draw the best straight line through your data that represents the relationship between input, which is your independent variable, and output, which is your dependent variable. And a real life example of this would be, imagine that you want to predict someone's salary based on years of experience. Linear regression, it finds the line that best fits the data points, like the formula written on your screen right here, where it says salary equals A times the years of experience plus B. Now, exactly why is this great? Well, it's super simple. It's easy to interpret, and it's a solid starting point for many problems. Now, its limitations are it only captures linear relationships, and it is sensitive to outliers. Next, let's talk about a decision tree. And a decision tree, this splits your data into branches based on questions like, is the person over 18? Do they own a car? Do they have a job? It just keeps branching until it makes a decision or a prediction. And a real life example of this will be a loan approval system. And it might include questions like your income level, your credit score, or your employment status. And basically the tree is going to lead you to a yes or no at the end of all of this to approve a person for a loan or not. Now, why is this great? Well, this is easy to visualize and explain, and it handles both numerical and categorical data, and there is no need to normalize or scale the data. Now, its limitations, it can overfit if the tree is too deep and is not always the most accurate on its own. All right, next we have what is called the K nearest neighbor. And this is all about finding similarities. It looks at the K closest data points to a new input and lets them vote on the result. So let's say you want to classify a new fruit as an apple or an orange. Well, the K nearest neighbor, it checks the closest fruits in the data set. And if 3 out of 5 neighbors are apples, then guess what? It's probably an apple. And this is how this is used in a real world example. So think of recommendation systems like Netflix or Amazon. They use the K nearest neighbor algorithm to recommend shows or products similar to what you and people like you have liked before. Now, why is this great? Well, there is no training step, so it's essentially lazy learning. It works well with very small data sets and is very intuitive. Now, its limitations, it can slow down with large data sets, and it is sensitive to irrelevant features or different scales. Then we have what is called the logistic regression, and this is used for classification problems like yes, no, or true or false outcomes. Now, unlike linear regression, logistic regression squeezes its output between 0 and 1 using something called the sigmoid function. So if the result is closer to 1, then it's going to likely produce an outcome of yes. If it's closer to 0, then it's going to be a no. In a real life example of how this is used, it can be used for predicting whether or not an email is spam or not spam. Now, why is this great? Well, it's simple and effective for binary classification. It outputs probabilities and it doesn't just do hard guesses, and it's easy to implement and interpret. Its limitations, it assumes a linear decision boundary and it doesn't perform well with complex relationships. Next, we have what is called the naive Bayes, and this is based on the Bayes theorem and assumes that all features are independent, which is often not true, hence the word naive. And it's all about using probability to guess the most likely class for a given output. And a real life example of this would be email spam filters. They really like this algorithm because it calculates the probability that an email is spam based on the words in it. And exactly why is this great? Well, it's extremely fast and efficient. It works surprisingly well with text data, and it can handle large data sets. Now, its limitations, it assumes feature independence, and it is not great for complex relationships. Then we have what is called the support vector machine. And SVMs, they try to draw the best boundary or a hyperplane between classes of data. It focuses on maximizing the margin between data points of different classes. So a real world example of this is SVMs. They are often used in image classification tasks like identifying handwritten digits. Now, exactly why is this great? Well, it is effective in high dimensional spaces, and it works well with both linear and nonlinear boundaries thanks to the kernel trick, and it's robust to overfitting. Now, its limitations, it can be slow on large data sets, and it's hard to tune its parameters. Then we have what is called the random forest, and this is an ensemble method. It builds many decision trees on random subsets of the data and averages the results. So you can think of it like crowdsourcing predictions. And a real life application will be using it for credit scoring or stock price predictions or even medical diagnosis. Now, why exactly is this great? Well, it reduces overfitting, is very accurate, and it can handle missing values and mixed data types. Its limitations is less interpretable than a single tree, and it's slower than simpler models. And then we have what is called the K-means clustering. And this is an unsupervised learning algorithm. Basically, it groups data into K clusters based on similarity without any labeled outcomes. So it's like going to a party and grouping guests by what they're wearing, even though no one told you who's who. How this could be applied in real life, it could be applied for customer segmentation for marketing, image compression, and identifying user behavior patterns. Now, exactly why is this great? Well, it's easy to understand and implement, it's fast and scalable, and it's great for exploratory analysis. Its limitations are, well, you have to choose the K manually. It's not great for irregular cluster shapes, and it is sensitive to initial starting points. All right, so I know that was a lot. So here is a handy little guide to help you choose the right algorithm if you're into this type of stuff. So go ahead and take a screenshot and get this in your life if you need it. Now, when it comes to algorithms, you got to understand that no algorithm is perfect and there is no best algorithm. Each one shines in specific scenarios, and the magic really happens when you understand the problem that you're trying to solve, you know your data, such as its size, type, and quality, and you try multiple models and then compare the results. Machine learning isn't about guessing the right tool for the first time. It's about experimenting, tweaking, and learning what works best. Now, to wrap all this up, At the end of the day, machine learning algorithms aren't mystical codes written in some secret AI language. They're just tools designed to help us find patterns, make predictions, and automate tasks in smart ways. So, linear regression, this is your go to for predicting numbers. Decision trees, this lets your data quote unquote speak for itself. K nearest neighbors, this finds friendly neighbors. Naive Bayes, this keeps things quick and simple. Logistic regression, this gives you clean classification. SVMs, these are for perfectionists. Random forest, this is for the wise crowd. And K-means is the quiet type that discovers hidden patterns. So the more you practice, the more intuitive these algorithms will feel. And once you really get the hang of them, you'll start to see machine learning problems not as overwhelming, but as exciting puzzles waiting to be solved. Now that we got that out of the way, let's do some check on learning. So, our first question is, which machine learning algorithm is best suited for predicting a continuous numerical value, such as housing prices based on square footage and location? Would this be linear regression, K nearest neighbors, decision tree classification, or naive Bayes? And the correct answer is this will be linear regression. So, linear regression is designed to predict continuous values based on the linear relationship between input values of your features and a target output. It's ideal for problems like forecasting prices, temperatures, or sales. The other options are either classification focused or based on probability. Next question. Which algorithm works by finding the most similar data points and using them to make a prediction? Would this be support vector machine, linear regression, decision tree, or K nearest neighbors? And the correct answer is K nearest neighbors. So this is an instance-based learning algorithm that stores all data and predicts outcomes for new data by finding the K closest training examples in the feature space. It's simple and effective for both classification and regression tasks. And our final question, what is a key advantage of using decision trees in machine learning? Is it they require a large amount of labeled data? They always produce better accuracy than other models. They are easy to interpret and visualize, or they can only handle numerical data. And the correct answer is they are easy to interpret and visualize. So decision trees are popular because they model decisions in a way that is easy for humans to follow. Their flowchart-like structure makes them interpretable. Now, unlike some other models, decision trees can handle both numerical and categorical data without extensive pre-processing. Have you ever asked Siri to set an alarm, or have you told Alexa to play your favorite song, or have you used Google Translate to understand a foreign menu? If so, you've already interacted with one of the most fascinating branches of artificial intelligence, and that is natural language processing. Now, you might be wondering exactly what is natural language processing? Is it just chatbots replying with cheeky answers? How does it actually work? And why is it so important in the AI world? All of those are great questions. And in this video, I'm going to break down the fundamentals of NLP, or natural language processing, and explore how it powers chatbots and translation tools, and give you a peek into how machines are learning to understand human language, which is arguably one of the trickiest things that they've ever been asked to do. So with all that being said, let's go. All right, so exactly what is natural language processing? Well, this is a branch of artificial intelligence that focuses on enabling machines to understand, interpret, generate, and respond to human language. In short, it's about teaching computers to talk with us and understand what we're saying. So think of NLP as a bridge between humans and machines. We speak and write in complex, messy, and nuanced language. Machines, on the other hand, they speak in ones and zeros. In NLP, this helps translate between the two. And it's not just about language recognition, it's about understanding meaning, context, intent, and sometimes even emotion. So why is natural language processing so hard? Well, language might feel natural to us humans because we learn it as toddlers and we constantly use it, but it's a minefield for machines. And the reasons is because of ambiguity. So you could say something like, I saw the man with the telescope, and the machine might be trying to figure out, well, did you actually use a telescope or did the man have it? And then there's issues with context. So you could say something like, I'm on fire, and that could mean you're literally burning up, or that could mean that you're doing something amazingly well. Then we have idioms and slang. So you could say something like spill the tea, or I'm about to hit the books, or break a leg. And to a machine, that could absolutely make no sense. Then there are synonyms and homonyms. So you could say the word bank, and that could mean a financial institution, or it could mean the side of a river. So when it comes to computers, they're really good at math and logic, but understanding all the weird quirks of human language, that takes some serious AI muscle. All right, so let's go over the building blocks of natural language processing. So before we explore applications like chatbots and translation, these are some of the core techniques and components that make NLP tick. The first is called tokenization, and this is breaking down a sentence into smaller parts or words or phrases. So we have the example of AI is awesome. You will break that down into AI, then is, and then awesome. Then we have what is called part of speech tagging. And this is where the computer will identify whether a word is a noun, verb, or an adjective. So if you say she plays the piano, then you need to identify she, which is the pronoun, plays, which is the verb, the, which is the determiner, and piano, which is a noun. You have what is called name entity recognition. And this is when you're finding names of people, places, brands, etc. in text. So you could say Apple is releasing a new iPhone in California. Well, Apple will be the organization, iPhone will be the product, and California will be the location. You also have what is called sentiment analysis, and this is used for determining the emotional tone behind text. So you could say something like, this movie was amazing, which would be positive, or you could say something like, I hated the ending, and that will denote a negative connotation. You also have what is called lemmatization and stemming, and this is reducing words to their root forms. So you take the word running, runs, or ran, and the root word is run. Then there's syntax and parsing, and this is understanding grammar and sentence structure. And then there's language modeling, and this is predicting what words come next in a sentence based on context. And this is how tools like ChatGPT write fluid, human-like text. So all of that are essentially the basic building blocks of natural language processing. All right, so modern natural language processing isn't just about rules and dictionaries, it's about machine learning. So instead of programming every single rule, we now feed massive amounts of text into models and let them learn patterns. And there are two major approaches. The first is traditional machine learning plus natural language processing. And this uses algorithms like decision trees or a naive Bayes. And this requires feature engineering where it manually selects what to analyze, like word frequency. And then you have what is called deep learning plus NLP. And this uses neural networks, especially transformers, which we'll talk about in a second. And it automatically learns features from data. And this powers modern tools like ChatGPT, Google Translate, and much more. And speaking of transformers, so transformers are a deep learning architecture that was introduced in 2017 that completely changed natural language processing. So transformers, what they can do is they can handle long range dependencies in text, like understanding that the cat mentioned 20 words ago is still relevant. It can also work in parallel, which makes training it much faster. And it can understand context and attention mechanisms to where they pay attention to which words matter the most. And the popular transformer-based models include the following. The first is called BERT, and that stands for Bidirectional Encoder Representation from Transformers. And this is great for understanding language. Then you have GPT, the one that we all know, and that stands for Generative Pre-trained Transformer. And this is great for generating language. So now let's go ahead and shift gears and look at how NLP powers one of the most visible and fun applications, and that is chatbots. So you probably chatted with a bot if you've ever asked a question on a company website, tried to book a flight online, or used a digital assistant like Siri or Alexa. So exactly what is a chatbot? Well, a chatbot, this is a computer program designed to simulate conversation with human users. And some are simple and rule-based, while others like ChatGPT are advanced and use deep learning. And there are two main types of chatbots. The first one is called a rule-based chatbot, and this follows scripted flows and it has limited responses. So an example will be something like press 1 for billing or press 2 for support. Then you have AI-powered chatbots, and they use natural language processing and machine learning to understand input and generate responses, and they can handle free-form language, and they essentially get quote-unquote smarter over time. Now, here's how smart chatbots work step by step. So the first step is called intent recognition. And this is where it figures out what you want. So you put an input in there like, I need to change my flight. And the detected intent will be, you need to change your flight. And then there's step 2, and this will be entity extraction. And this is where it finds key information. So in your input, you might put something like change my flight from New York City to LA on Friday. And then the entities that it identifies is New York City is the origin, LA is the destination, and Friday is the date. And then the next step is called dialogue management. And this is where it decides how to respond, where it might ask you something like, would you like to change the departure or return flight? And then there's response generation to where it replies in natural language, where it might say something like, okay, I've updated your departure flight to Los Angeles on Friday. And all of this happens in a few seconds, thanks to natural language processing magic that's taking place behind the scenes. Now, another fascinating application of NLP is language translation. So imagine typing a sentence in English and getting a perfect translation in Spanish, Japanese, or Swahili in a matter of seconds. Now, we take all of that for granted, but this can be incredibly complex. So let's talk about the challenge of transition. So languages, they are wildly different. Word orders vary. So in English, you might say, I eat sushi. But if you did a direct translation to Japanese, instead of you saying, I eat sushi, it'll come out saying sushi, I eat. And then some languages have genders, some are formal versus informal, and some have unique grammar rules. And then also there are cultural nuances that can change meanings. Now let's walk through how translation systems evolve. So we have what is called the rule-based translation, and this used grammatical rules and dictionaries, and this required tons of human effort, and it was not very flexible. Then we have what is called statistical machine translation, and this learned from bilingual texts. It analyzed which words usually map to which, and it still struggled with grammar and context. Then we have what is called neural machine translation, and this uses deep learning and neural networks. It can translate entire sentences, not just word by word. It can capture meaning and context, and it is much more fluent and natural. So the most famous example would probably be Google Translate, which now uses neural machine translation, and this gets better with every sentence that you feed it. All right, next let's quickly talk about transformer-based translation. So modern translation systems, they use transformer models just like chatbots. So here's the basic idea. So you have an encoder, and this reads the input sentence like you saying, I love learning. Then there's the decoder. So this generates the output sentence in the target language to where it'll transform I love learning into its French equivalent. Then you have what is called an attention mechanism, and this ensures the right words are matched. So the word love in English, this will map to the word adore in French. And because these models are trained on massive amounts of bilingual data, they get surprisingly good at capturing nuance and even capturing slang. All right, so let's go over some real world examples of how natural language processing takes place every day in your life, even if you don't realize it. So we have email spam filters. So NLP, this helps filter messages based on text analysis. You have autocorrect and predictive text. So your phone guessing what you'll type next, that's natural language processing. Voice assistants, so Alexis and Siri, they rely heavily on NLP to interpret your speech. It can be found in customer service. So you have automated agents that handle questions in retail, banking, and tech support. They're using NLP. Then you have sentiment analysis tools. So brands, they can monitor Twitter or reviews to track how customers feel. All of that is natural language processing. And here are some ethics and challenges associated with natural language processing. So the first one is bias. So if models are trained on biased data, then they're going to produce biased outputs. So for example, they might associate certain professions with a particular gender. Then there's privacy concerns. So chatbots and translation tools, they may process sensitive user data. So we need to figure out, how do we ensure that that data is being kept private? Then there's misinformation. So generative models, they can create fake news or misleading content. And then there's misunderstanding context. So even advanced natural language processing can misunderstand jokes, sarcasm, or cultural context. And that's why researchers emphasize responsible AI development and regular audits. So exactly what is next for natural language processing? Well, the field of NLP is moving fast. And so here are some exciting frontiers. So you're going to have multilingual models, and this will be one model that understands dozens of languages. You're going to have emotion-aware chatbots, and these are going to be bots that detect your mood and respond empathetically. They're going to have AI writing assistants. So tools like Grammarly, they're already out there where they can help you create content. Then you're going to have voice plus text integration, where it's going to blend speech recognition and NLP to create richer interactions. And as these tools get smarter, so does our need to understand them, which is exactly what you're currently doing right now by watching this video. All right, so here are all the key takeaways. So natural language processing isn't just about talking to machines. It's about creating a world where machines can talk to us, understand us, and even help us communicate across cultures and continents. So whether you're chatting with a bot, translating a phrase, or just enjoying autocorrect saving you from embarrassing typos, NLP is quietly working in the background. And as you continue your AI fundamentals journey, Just remember, every great AI conversation starts with a simple goal, and that is understanding each other. And so, with that being said, now you have a basic understanding of how natural language processing works. All right, so let's do some check on learning. So, the first question is, what is the primary goal of natural language processing? Is it to translate computer code into human readable formats? Is it to enable machines to understand, interpret, and respond to human language? Is it to store large amounts of text data in databases? Or is it to create artificial emotions in chatbots? And the correct answer is it is to enable machines to understand, interpret, and respond to human language. So NLP, this is a branch of AI that focuses on allowing computers to understand and work with human or natural language. Its goal is to bridge the gap between human communication and machine understanding. Next question. Which of the following is a common ethical concern with NLP-based chatbots? Is it slow processing speeds? Is it the use of outdated language models? Is it bias in response based on training data? Or is it the inability to store user data? And the correct answer is it is bias in response based on training data. So NLP models learn from large data sets, and if those data sets contain biased, offensive, or misleading information, the chatbot can replicate those patterns. And this raises ethical concerns about fairness, representation, and responsible deployment. And our final question, how does NLP support language translation applications like Google Translate? Is it matches words to images stored in the database, or it relies entirely on rule-based dictionaries, or it analyzes sentence structure and meaning to generate accurate translations, or it randomly generates text based on user preferences? And the correct answer is it analyzes sentence structure and meaning to generate accurate translations. So NLP uses techniques like syntax parsing, semantic analysis, and machine learning to understand sentence structure and meaning. And this enables more accurate and context-aware translations between languages. Let's play a game. Look around wherever you are right now. Do you see your phone? Do you see a coffee cup? Maybe there's a dog lying on the floor or a car that's passing by outside. Now, imagine teaching a computer to see all of those things, not just to see them, but to actually understand what it's looking at. That, in a nutshell, is what computer vision is all about. Now, it sounds wild, but we're already living in a world where computers recognize faces, detect diseases in x-rays, and help self-driving cars figure out when to stop at a red light. So in today's video, I'm going to break down what computer vision is, how it works, and explore two foundational concepts in the field, and that is image classification and object detection. So whether you're brand new to this or you just want to finally make sense of these buzzwords, well, you're in the right place. So let's get to it. All right, so first things first, exactly what is computer vision? So let's go ahead and keep it simple. Computer vision, this is a field of artificial intelligence that trains machines to see and make sense of the visual world. We humans, we do this all day, every single day, without even thinking about it. Our eyes can take in the world and our brains interpret what we're seeing, whether it's a cat, a stop sign, or a facial expression. With computers, the process is more mechanical, but the goal is the same, and that is to help machines understand and act on visual data. Now, the next question is, why is computer vision such a big deal? Well, here's why this field matters so much. When it comes to healthcare, AI can detect tumors in medical scans faster than human doctors. When it comes to autonomous vehicles, self-driving cars, they can use cameras and vision to help navigate. When it comes to retail, smart stores that use vision to track products and detect theft. When it comes to security, computer vision uses facial recognition for access control and surveillance. When it comes to agriculture, drones can scan crops for health, hydration, and pests. And when it comes to accessibility, there are applications that can help visually impaired users identify objects or read text out loud. And that's just scratching the surface. Computer vision is essentially everywhere and is growing extremely fast. So how does computer vision actually work? Well, let's walk through the basic idea using an example. So say you want to teach a computer to recognize pictures of dogs. You start with a bunch of dog images. The computer doesn't see a dog in the way that we do. All it sees is numbers, i.e. pixels and color values. Now, through a process called training, We help the computer learn patterns that distinguish a dog from a loaf of bread or a bicycle. And the more data that it sees, the quote unquote smarter it gets. All right, so let's zoom in on two of the most foundational and fascinating applications of computer vision. And the first one we're going to talk about is called image classification. And then we're also going to talk about object detection. Now, both are related, but they serve different purposes. So let me go ahead and break them down. So let's talk about image classification first. So imagine that you give AI a photo and then you ask it, what is in this image? If the AI responds with just one label, like dog or pizza, then that's image classification. And if you want a formal definition, well, image classification, this is the process of assigning a label to an image from a fixed set of categories. So think of it like sorting pictures into folders. All the cat pics will go into the cat folder, all the car pics go into the car folder, and all the pizza pics will go into the pizza folder. So here are some real world examples of how image classification is being used. You could find it being used in Instagram and Facebook, where it automatically tags your friends. It's used in medical imaging tools for detecting whether a scan is healthy or abnormal. It's also used in wildlife conservation, where drones are used to classify animals and photos. And it's also used in email filters for recognizing and classifying spam based on images. Now, exactly how does all of this work? Well, behind the scenes, the process usually looks like this. So the first step is called data collection. And this is where you gather thousands or millions of labeled images. So for example, you have a bunch of photos that are labeled as cat, dog, car, etc. Then the next step is called pre-processing. And this is where images are resized, normalized, or converted to grayscale to reduce complexity. Then there's step 3, where you train the model. So you can use a machine learning model where they often use what is called the convolutional neural network, or CNN, to learn from the images. And then there's step 4, it's called testing and inference. So once the model is trained, you can feed the model a new image and it will predict the most likely label. All right, so the other pillar is called object detection. So image classification is great, but what if there are multiple things in the image? So say you're looking at a photo of a dog, a ball, and a tree. You don't want to know what's just in the image. You want to know what is there and where is it in the image. And that's where object detection comes in. And a formal definition of object detection is basically identifies multiple objects within an image and draws bounding boxes around them, labeling each object. So instead of saying there is a dog, the algorithm will say there's a dog at coordinates x1, y1, there's a ball at x3, y3, and a tree at x5, y5. And real world applications of how this stuff works. So once again, we have autonomous vehicles, and this type of technology can be used for spotting pedestrians, street signs, and other vehicles. It's used in retail, where it can detect products on shelves for inventory management. It's used in security cameras for recognizing people or unusual objects. It's also used in sports analytics, where it can track players, the ball, and movement patterns. And of course, it's used in smartphone cameras, where it can enhance autofocused facial detection. Now, exactly how does object detection work? Well, it's a bit more complex than classification, but let me go ahead and try to simplify it. Step 1 is called annotated training data. And this is where you need images with bounding boxes and labels for each object in them. So an example will be a person box, a bicycle box, or a dog box. Then there's step 2. This is when you would train an object detection model. And some popular architectures for object detection include YOLO, SSD, and faster RCNN. And these models basically detect and localize multiple objects simultaneously. And then there's step 3, which is output. So you feed an image and the model spits out coordinates of bounding boxes. It also tells you the predicted object in the box. And then it gives you a confidence score. Like it'll say something like, I'm 93% sure that this is a truck. And here's a quick side-by-side comparing image classification versus object detection. So go ahead and take a screenshot and get that in your life if you need it. Now let's talk about some challenges that are associated with computer vision. So computer vision is powerful, but it's not perfect. And here's a few common challenges. The first is lighting and weather. So a model that is trained on sunny photos, it may struggle on rainy days. You have angles and perspectives. So an object viewed from a weird angle, this might confuse the system. You have what is called occlusion. So basically, what if there is a dog behind a chair? Will the AI still be able to recognize it? You have bias and training data. So if a facial recognition model is trained mostly on one ethnicity, it may perform poorly on others, which could lead to dangerous consequences. And then there's processing power. You have high-end vision models, especially those real-time ones. They can be super demanding. Now, these challenges are why researchers are constantly refining algorithms, data collection methods, and fairness metrics. All right, so let's go ahead and wrap this lesson up. So, computer vision, this is the bridge between the digital and physical worlds. It helps machines recognize, understand, and interact with the world around them. It powers everything from Google Photos to robot navigation systems. And with tools like image classification and object detection, it makes things smarter, safer, and more efficient. But the journey doesn't stop there. So, as you continue your AI fundamentals journey, just think about this. How would you want an AI to see the world? What data would you feed it, and how would you ensure it sees fairly and accurately? Because training an AI to see isn't just a technical challenge, it's a human one as well. And with all of that being said, let's do some check on learning. So, our first question is, which of the following best describes image classification in the context of computer vision? Is it identifying multiple objects in an image and drawing boxes around them? Is it assigning a single label to an entire image based on its main content? Is it predicting the location of key facial features in a photo? Or is it tracking an object across a video stream over time? And the correct answer is it is assigning a single label to an entire image based on its main content. So, image classification involves analyzing an image and assigning it to a specific label from a predefined set of categories. Unlike object detection, which can identify multiple objects and their locations, classification is about determining the overall category of the image as a whole. Next question. What is the main difference between image classification and object detection? Is it object detection works only on videos while image classification works on still images? Is it image classification labels every object separately while object detection labels only one? Is it object detection identifies both the label and the location of multiple objects in an image? Or is it image classification uses deep learning while object detection does not? And the correct answer is object detection identifies both the label and the location of multiple objects in an image. So, object detection not only classifies objects within an image, but also pinpoints their positions using bounding boxes. Image classification, on the other hand, classifies the image as a whole without locating individual items. And our final question, which of the following is a potential ethical concern related to computer vision systems? Is it using grayscale images instead of color for training? Is it relying on data sets that lack diversity leading to bias recognition? Is it applying data augmentation to improve model accuracy? Or is it using convolutional neural networks for edge detection? And the correct answer is it is relying on data sets that lack diversity, leading to bias recognition. So, one major ethical challenge in computer vision is data set bias. If training data is not diverse, the resulting models may perform poorly on underrepresented groups, leading to real world or unfair treatment. Have you ever read a poem that brought tears to your eyes, only to discover it was written by a machine? Or have you seen a stunning digital portrait of a dragon surfing astronaut and found out that no human painted it? Well, welcome to the world of generative AI, where machines don't just analyze data, they actually create stuff. We're talking full on content creation, such as writing, art, music, code, and even memes. In this video, this is going to be your beginner friendly deep dive into generative AI. We're going to explore what it is, how it works, and why it's revolutionizing everything from storytelling to science. By the end, you're going to understand the magic and the mechanics behind AI generated text and images. Let's begin by asking, what is generative AI? Well, let's go ahead and keep it simple. Generative AI, this is a type of artificial intelligence that creates new content from data it has learned. We're not talking about a machine repeating things it's seen before. We're talking about machines that can write entire essays, compose original music, generate realistic images, code websites, design logos, and create deepfake videos. And the key idea is it is creation, not just recognition. So while traditional AI is great at recognizing patterns, like identifying spam emails or faces in photos, generative AI takes it a step further. It uses those patterns to make something new. And here are a few quick real life examples. So let's say you tell your generative AI to create an image of a golden retriever wearing a spacesuit on the moon, holding a flag that says, I wolf you. And then seconds later, it spits out that exact same image. Or maybe you type something like, write a bedtime story about a lonely robot who finds a family. And then you get a touching tale that can easily pass for something of a children's book. That is generative AI in action. Now, understand, generative AI is not brand new, but it's having a major moment. So, why is this thing exploding now? Well, there are two reasons. First, there is huge amounts of data floating around out there. So AI models today, they're trained on massive data sets, like all the text on the internet or millions of images. And then there are powerful neural networks. So deep learning, especially something called transformers, they make it possible to generate content that's shockingly human-like. And with that foundation laid, let's go ahead and talk about the two most popular types of generative AI, and that is text and images. All right, so what is AI generated text? Well, AI generated text is any written content that's created by an algorithm rather than a human. And this could be articles, stories, poems, product descriptions, scripts, email, and even entire books. These systems can write everything from technical documentation to haikus, and they're only getting better. Now, how does all this stuff work? Well, let's break it down using the most well-known example, and that is called a large language model, or an LLM. And these are AI models that are trained on enormous amounts of text, from books and websites to news articles and Reddit threads. And GPT, which stands for Generative Pre-trained Transformer by OpenAI, this is a famous example, also known as ChatGPT. So here's an example of how all of this works. You have training. So the AI reads, or more accurately, processes billions of words and learns how language works in terms of grammar, tone, structure, and style. Then there's prediction. So given a prompt or a question, the AI predicts the next most likely word, then the next, and then so on and so on. And it's kind of like autocomplete, but supercharged. And then there's generation. So by stringing words together based on probability, it generates full paragraphs, essays, poems, and whatever else you can think of. And the more advanced the model, the more fluent, coherent, and weirdly human the output feels. And here are some popular use cases for AI generated text. So it can be used in marketing, where marketers create ad copy. They use it for social media captions and email campaigns. It's used in education, where it can be used for writing study guides, generating quizzes, or tutoring support. It's used in business for drafting reports, meeting notes, and chatbots. It's used in entertainment for crafting storylines for games or screenplays. And it's used for accessibility by helping people with disabilities communicate more easily. And as far as creators are concerned, it's like having a brainstorming partner who never runs out of ideas. But now the question is, can it really replace human writers? Well, not quite. AI generated text can sound impressive, but it does have its limitations. It doesn't understand what it's writing. It can produce false or misleading information, and it struggles with humor, sarcasm, and nuance. So in short, it's a powerful assistant. It's not a perfect author. So think of it as a co-writer who's read everything that was ever written, but doesn't know what's true or what matters most. Now let's talk about AI generated images. So exactly what is it? Well, AI generated images are pictures that are created by algorithms, and they can range from photorealistic portraits to abstract art to cartoons and animation to logos and branding to fake celebrity photos, which are known as deepfakes, and to fantasy worlds. And they're created by entering text prompts like, give me a picture of Sylvester Stallone with gold teeth and gold chains holding a microphone rapping. And then seconds later, boom, you have a picture of Sylvester Stallone with gold teeth and gold chains holding a microphone rapping. Now, how does all of this work? Well, most popular engine generation tools, they use models that are trained on millions of images. And the model learns what objects look like a cat, a mountain, or a human face, how the styles work, such as cubism versus realism versus anime, and how to match images to descriptive text. And three of the most popular models are as follows. So you have what is called DALL-E, and that was created by OpenAI. You have Midjourney, and you have another one called Stable Diffusion. And they use a process called diffusion. And this is where random noise is gradually turned into a clear image guided by the text prompt. So imagine starting with static on a TV with no signal. Then frame by frame, the picture sharpens into your vision. And here are some common use cases for AI generated images. So they're used by graphic designers, where they can create instant mock-ups, logos, and posters. Marketers use them for creating visuals without using stock photos. Education uses them for creating visual aids, diagrams, and art based learning. Entertainment uses it for game assets, concept art, and comics. And social media definitely uses it for meme creation and content styling. Also, it's empowering people who don't consider themselves artists to bring their ideas to life by simply just typing. Now, while generative AI images are amazing, they can also be controversial. And some of the controversies are art theft because models they are trained on publicly available artwork, sometimes without the original artist's permission. There's also the controversy of misinformation because it's easy to generate fake or misleading images. Then there's deep fakes. So AI can be used to impersonate people for malicious reasons. And then there's job disruption. So some artists, they worry about being replaced or devalued. So like all powerful tools, it just depends on how you use it. Now let's talk about how generative AI is changing the world. So generative AI isn't just a fun trick. It's changing industries, workflows, and creativity itself. And here's a glimpse of the bigger picture. So in journalism, AI can draft news stories, summarize long articles, or translate instantly. In film, AI is being used to de-age actors, create digital doubles, and even write scripts. In medicine, generative AI can simulate how a disease progresses or how a new drug might work. In education, teachers are using AI to create custom learning materials on demand. And in personal use, people are writing books, composing music, generating art, and building businesses with AI support. So essentially, it's like adding rocket fuel to your imagination. Now, here's the $1 million question. Can a machine actually be creative? Well, this all depends upon your definition of creativity. So, if creativity means producing something new and useful, then AI qualifies. If creativity requires emotion, intention, and personal meaning, then probably not. AI, it does not feel inspired. It does not dream, but it can remix, reimagine, and regenerate based on everything it's learned. So maybe it's not creative in the way that a human is, but it sure looks like it. So, with all of that being said, with great power comes great ethical debates. And here are a few big ones. First one is originality versus plagiarism. So, if AI paints in the style of a famous artist, is that considered art or theft? Then there's consent and privacy. So, what if AI trains on your face, your voice, your writing without asking? Is that going to be a problem? There's misinformation. What happens when people can't tell if something is real or fake? And then there's bias. So generative AI can inherit bias from its training data. So for example, it might underrepresent certain races, genres, or cultures. And these are huge questions and ones that we're going to need to face head on as this technology continues to evolve. And here on your screen is a summary of everything that we just talked about. So go ahead and make a screenshot and get that in your life if you need it. Now, to wrap all this up, generative AI is more than a buzzword. It's the dawn of a new creative revolution. Machines are no longer just tools for analysis or automation. They're becoming co creators, whether it's helping you brainstorm, design, write, or visualize. AI is blurring the lines between artist and algorithm. And of course, this raises serious questions about ethics, originality, and what it means to be creative. But it also unlocks incredible potential, especially when humans and AI work together. So the next time you see a piece of art or you read a beautifully written paragraph, don't be too quick to assume a human made it. You might just be admiring the work of a very talented machine. Now, with all that being said, let's do some check on learning. So our first question is, which of the following is a potential ethical concern when using AI generated text in journalism? Is it the AI writes too slowly? Is it the text may be fact checked automatically? Is it the article includes too many hyperlinks? Or is it the AI may generate false or misleading information? And the correct answer is the AI may generate false or misleading information. So, generative AI models can sometimes produce content that sounds plausible, but it's factually incorrect or biased. And when used in journalism, this poses ethical risks such as spreading misinformation or violating public trust. Next question. Why is disclosure important when sharing AI generated images on social media? Is it increases the image resolution? Is it prevents unauthorized downloading? Is it ensures viewers know the image isn't real or human made? Or is it improves the AI's future performance? And the correct answer is it ensures viewers know the image is not real or human made. So clearly labeling AI generated images, this helps avoid misleading viewers, especially in contexts like news, politics, or product endorsements. Ethical AI use involves transparency so people aren't tricked into believing something is authentic when it's synthetic. And our final question is which of the following best demonstrates a responsible use of generative AI in content creation? Is it using AI to create fake product reviews to boost sales? Is it creating art with generative AI and crediting the model or tool that was used? Is it posting AI generated medical advice without disclaimers? Or is it using AI to impersonate someone without their permission? And the correct answer is it is creating art with generative AI and crediting the model and tool that was used. So, responsible AI use means being transparent about AI involvement, respecting intellectual property, and avoiding deceptive or harmful practices. Crediting the tool promotes honesty and respect for AI ethics. All right, so you've already wrapped your head around the basics of artificial intelligence. You know the difference between narrow AI, general AI, and superintelligence. And you're clear on machine learning versus deep learning. And maybe you've even chatted with an AI chatbot or asked Alexa to play your favorite song. But now it's time to go beyond the theory. So let's talk about where AI really comes to life in physical machines that can move, act, and even make decisions on their own. We're talking about robots, autonomous systems, and smart devices. And these aren't just futuristic toys anymore. They're real, they're powerful, and they're changing our world. So by the end of this video, you'll understand how AI is used in robotics, what makes a system autonomous, and how smart devices use AI to learn, adapt, and assist. And most importantly, you'll be able to see how all of these parts fit together in your everyday life. All right, so let's talk about advanced AI topics. So think of advanced AI topics as real world applications that go beyond just software. Instead of just running in the cloud or on your smartphone, AI is now baked into machines that interact with the physical world. You can think of your vacuum that can map your living room. You can think of a car that can park itself. Or you could think of a smart thermostat that can learn your habits and adjust the temperature without you lifting a finger. This isn't just software that talks, this is software that actually acts. Let's start with a crowd favorite, and that is robots. So when you picture a robot, what comes to mind? A humanoid machine, a factory arm that's assembling cars, or a cute robot dog. Well, all of these are fair game. But what makes them smart is artificial intelligence. So, exactly what is a robot? Well, a robot, this is a physical machine that can carry out a series of actions automatically, especially ones that are programmable and interactive. And then when you add AI to the mix, then suddenly your robot can sense its movement, make decisions, learn from feedback, and adapt to new situations. And this turns a dumb machine into a smart, flexible agent. And here's some examples of AI powered robots. So we have industrial robots, and they are found in factories, warehouses, and production lines. They use AI to detect objects, adjust their grip, and optimize workflow. An example, which you can see on your screen right here, are Amazon warehouse robots that can move shelves around to fulfill orders faster. There are also healthcare robots, and they help with surgeries, patient care, hospital logistics. An example of this would be the Da Vinci surgical system, which assists doctors in performing complex procedures with robotic arms that are controlled by human surgeons that are guided by AI algorithms for precision. You also have service robots, and these include robots that clean, deliver, or even entertain. An example of this would be SoftBank's Pepper robot, which can greet customers, answer questions, and even read emotions. You also have exploration robots, and they are used in deep sea research, space missions, and hazardous environments. An example of this would be NASA's rovers on Mars, where they use AI to navigate terrain and collect samples. So, what exactly does the AI do inside of a robot? Well, for some, it can provide computer vision where it can recognize people, objects, and environments. Some of them engage in natural language processing where they can understand and respond to human commands. Some do reinforcement learning where they can improve performance through trial and error. And some do motion planning where they can figure out how to move around without bumping into stuff. So AI, this is the brain, and robotics is the body. Now, without AI, a robot can only follow strict instructions. But with AI, it can react, learn, and even make decisions. All right, so let's talk about AI and autonomous systems. So, an autonomous system, this is any machine or technology that can operate without direct human control. That doesn't mean that it's running wild. but it does mean it can assess its environment and make decisions on the fly. And guess what? AI makes all of this possible. All right, so let's talk about self driving cars. And this is probably the most famous autonomous system, with companies like Tesla, Waymo, and Cruise are pouring billions into making cars that can detect lanes, signs, and obstacles. They can predict pedestrian and driver behavior. They can decide when to speed up, slow down, or stop. And they can navigate unfamiliar roads without GPS micromanagement. And all of this happens in real time thanks to AI algorithms that are trained on terabytes of sensor data from cameras, LiDAR, radar, and GPS systems. And when it comes to autonomous systems, they are often ranked on a scale from 0 to 5. And I'm not going to read all of this to you, but most self-driving cars today, they are stuck somewhere between levels 2 and 3. Now, when it comes to being a true autonomous system or level 5, we're not there quite yet. And then we have other examples of autonomous systems. So we have drones. So there are AI powered drones that can fly without a pilot, avoid obstacles, and capture footage based on real time object tracking. You have autonomous ships. So companies like Rolls-Royce are developing AI driven cargo ships that can navigate oceans without a crew. You have military robots, and they're used for surveillance, bomb disposal, and even combat simulations. And these systems, they must make split-second decisions under pressure. Now, what powers autonomous AI? Well, to achieve autonomy, systems that rely on what is called sensor fusion, and this is combining input from multiple sensors to understand surroundings. It also relies upon perception models where it can recognize objects and predict behavior. There's path planning where it can decide the safest and most efficient route. And then there are control systems where it can translate decisions into physical movement. And together, these form a closed loop of sensing, thinking, acting, and repeating. All right, next let's talk about AI and smart devices. So if robots are the body and autonomous systems are the driver, then smart devices are like little AI assistants living inside of our homes, pockets, and workplaces. So exactly what is a smart device? Well, a smart device is any gadget that uses sensors, connectivity, and AI to understand your needs, learn your habits, respond to commands, and optimize tasks automatically. Now, unlike traditional electronics, smart devices are context aware. Basically, they're designed to make your life easier by doing things before you even ask. And here are some everyday examples of AI when it comes to smart devices. So you got smart speakers like Amazon Echo, Google Nest, or Apple HomePod, and they use natural language processing to understand your voice. They can answer questions, play music, control your lights, and learn your preferences over time. You have smart thermostats like Nest, and they can learn when you leave and return back home. They can adjust temperature automatically to save energy, and they can predict your comfort preferences over time. You have smartphones where they use AI for face recognition, photo enhancement, battery optimization, and predictive typing. Your smartphone camera uses computer vision to blur backgrounds or detect senses, and your apps recommend content based on behavior thanks to machine learning. You also have wearables like Apple Watch and Fitbit, where they can track steps, heart rate, sleep patterns, alert you if your heartbeat is irregular, and they can use AI to detect patterns that even doctors might miss. And you also have smart appliances. So you have refrigerators out there that can tell you when your food is expiring. You have washing machines that choose optimal cycles based on load type. And you have AI ovens that recognize food and adjust cook time. Now, smart homes aren't just about convenience. Overall, they're about efficiency, personalization, and proactive decision making. So when it comes to smart devices, exactly how do they learn? Well, AI and smart devices are often powered by edge computing, and this is processing data directly on the device instead of sending it to the cloud. There's also what's called federated learning. This is sharing learning across devices while keeping your data private. And then you have what is called behavior modeling, and this is recognizing patterns in your habits to make accurate predictions. And also don't forget, data is everything. So the more your device knows about you, the better it gets at serving you. Now, some people think this is creepy and some think it's cool, but you got to be the one that makes the ultimate decision on that. Now, all of these things have one common thread, and that is AI is the engine. So whether it's a robot in a warehouse, a car navigating traffic, or a smartwatch monitoring your heart, the engine driving all of these technologies is artificial intelligence. Now, why does this matter? Well, understanding how AI interacts with the physical world helps you visualize the future of tech in your home, car, or job. It can help you make informed decisions about buying or using smart products. It can help you understand the challenges around AI safety, ethics, and privacy. and it can help you explore career opportunities in the field that blend AI with robotics, engineering, or user experience. So, what's next in this space? Well, we're only scratching the surface of what AI powered machines can do, and some future developments include the following, such as fully autonomous delivery robots that are roaming sidewalks. You're going to have smart cities where traffic lights adjust to real time traffic flows. You're going to have AI enhanced medical robots performing precise surgeries with minimal supervision. You're going to have collaborative robots working side by side with humans on job sites. And you're going to have emotionally aware smart devices that respond to your mood or stress levels. Now, as these technologies grow, so do the ethical and legal questions, such as who's responsible if an autonomous drone crashes? What data should your smart speaker be allowed to collect? How do we keep AI systems aligned with human values? Now, these are the challenges and the opportunities that come with living in an intelligent world. So, to wrap this lesson up, AI isn't just about software anymore. It's crawling into our homes, driving on our roads, walking around in factories, and helping us live longer, safer, and smarter lives. Robotics gives AI a body. Autonomous systems give it freedom, and smart decisions make it personal. Now, these advanced applications are shaping the future of how we live, work, and connect. And as AI continues to evolve, understanding these tools won't just be useful, it'll be essential. So the next time your robot vacuum maps your living room or your car parallel parks itself, take a moment to appreciate the magic behind the machine. That is artificial intelligence at work. All right, now with all that being said, let's do some check on learning. So, our first question is which of the following best describes the role of AI in autonomous vehicles? Is it AI controls only the vehicle's air conditioning system? Is it AI is used to interpret sensor data, make real time decisions, and navigate safely? Is it AI monitors the driver's health but doesn't influence vehicle movement? Or is it AI powers the car's radio and entertainment system? And the correct answer is AI is used to interpret sensor data, make real time decisions, and navigate safely. So, AI in autonomous vehicles is responsible for interpreting inputs from cameras, LiDAR, GPS, and other sensors to make decisions in real time, like braking, accelerating, steering, and avoiding obstacles. And this is a crucial function that allows autonomous systems to mimic human driving behavior. Next question. Which of the following is an example of a smart device using AI for personalized user experience? Is it a basic thermostat with manual controls? Is it a blender with a single power setting? Is it a smart speaker that learns your music preferences over time? Or is it a television that only uses preset channels? And of course, the answer is a smart speaker that learns your music preferences over time. So, smart speakers like Amazon Echo or Google Home, they use AI to understand voice commands, process language, and learn user habits and preferences. And over time, they tailor recommendations like songs or reminders, making the experience more personalized. And our final question. What ethical concern is most relevant when using AI powered surveillance robots in public spaces? Is it the cost of manufacturing the robot? Is it the color and design of the robot's exterior? Is it the potential for bias and violation of privacy rights? Or is it the battery life of the robot? And the correct answer is the potential for bias and violation of privacy rights. So, AI surveillance systems may raise serious concerns about data privacy, constant monitoring, and algorithmic bias, especially if facial recognition is involved. Now, ethical AI practice this requires transparency, fairness, and respect for individuals' rights. All right, so let's talk about something most people don't associate with artificial intelligence, and that is bias. So, when we think about AI, we often imagine perfectly logical, objective machines calculating numbers, making decisions, and solving problems without emotion or judgment. But here's the twist: AI is only as good or bad as the data and humans behind it. And that means bias isn't just possible in AI, it's inevitable if we're not careful. So, in this video, we're going to explore what bias in AI actually means, where it comes from, how it can lead to discrimination, and most importantly, what can we do about it? Whether you're building AI systems or just using them, this is a topic that you need to know. So, let's go ahead and break it down. First, what do we mean by bias in AI? So, in everyday life, Bias, this usually means having an unfair preference or prejudice. In AI, it's a bit more technical, but just as impactful. So, bias in AI, this refers to systematic errors in the output of a model that unfairly favors one group over another. So, in plain terms, if your AI treats some people better or worse than others based on factors like race, gender, age, or background, then that's a biased system. And sometimes the bias is subtle, sometimes it's shockingly obvious. Either way, it's a problem that can have real world consequences. Now, before we dive into where bias comes from, let's look at some examples where things went wrong. We have facial recognition. So, studies by MIT and others found that commercial facial recognition systems were significantly less accurate at identifying black and brown faces, especially for women. In one case, error rates for white males were under 1%, while for black females, it was over 35%. And that's not just a bug, this is a trust and safety issue. Another example is hiring algorithms that discriminate. So in 2018, Amazon scrapped an internal recruiting tool after discovering it downgraded resumes with the word women's in it, as in women's chess club captain. Now, why was this? Well, the model had trained on resumes submitted over a decade, which were mostly by men. So essentially, the algorithm had come to learn that male equals good candidate and women equals bad candidate. And then there's healthcare algorithms that have racial bias. So, a widely used healthcare risk prediction algorithm underestimated the health needs of Black patients. And as a result, fewer Black patients were identified for extra care, even though they were just as sick as white patients. Now, the issue, the algorithm used healthcare costs as a proxy for healthcare needs, but historically, Black patients have received less care, so their costs were lower. So now that we've seen how bias can show up in real systems, let's unpack the key sources of bias in AI. And they generally fall into two broad categories. You have bias in data and bias in models and development processes. So let's go ahead and dig a little deeper into both. And we're going to start with bias in data. So let's get one thing straight. AI learns from data. That means if the data is flawed, the AI will be too. So always remember garbage in and garbage out. And here are some ways bias can creep into data sets. So you have historical biases, and this happens when the data set reflects past discrimination or inequality. So an example would be if you train a hiring algorithm on data from a company that's hired mostly men, your AI will learn that men are better candidates. Now, it's not malicious, it's just learning the pattern it sees. But those patterns reflect historical inequality. And then you have sampling bias. And this occurs when your data set is not representative of the real world population. So an example would be if you build a voice assistant using only American English speakers, it may struggle to understand accents or non-native speakers. And the bottom line, if your data set leaves people out, so too will your model. Then you have labeling bias. So in supervised learning, humans label the data. But guess what? Humans can be biased, whether intentionally or not. So, an example would be in sentiment analysis, labeling a comment like "you're loud" as negative might reflect cultural or personal bias. And labeling bias, this often reflects the assumptions of the annotators. And that's a problem when those labels are used to train AI. And then you have measurement bias. And this happens when the features used in the data do not accurately reflect what you're trying to measure. So an example would be using zip codes as a proxy for income or credit worthiness. This might encode racial or socioeconomic bias into your model. And you might think that your model is neutral, but the inputs are always skewed. Now, even with good data, bias can still sneak in during development and deployment. And we have what is called algorithmic bias. So some algorithms, they inherently favor majority patterns in the data and ignore outliers. An example of this would be a model that is trained on 90% male data might not learn enough about female patterns because it focuses on the most common data. Then you have what is called a training imbalance. So if a model sees more examples of one group during training, it may perform better for that group. So think of it like this. If your model saw 10,000 photos of dogs and only 100 of cats, it'll be much better at identifying dogs. Now that's fine for pet pictures, but dangerous in healthcare, criminal justice, or hiring. You have what is called feature selection bias. So sometimes the features that developers choose to include in the model can introduce bias, whether intentionally or unintentionally. So an example would be including race or gender as a predictor, even indirectly, because this can lead to discriminatory results. You have what is called evaluation bias. So if you test AI on the same kind of data it was trained on, it might look great until it fails in the real world. An example of this would be your facial recognition that works on your test set, but it struggles in the wild with people of different ethnicities or lighting conditions. And this is why diverse testing is crucial. Do you have what is called bias in the development team? So here's the hard truth. Who builds the AI? This actually matters. So if your team lacks diversity in gender, race, culture, and lived experience, you're more likely to overlook key risks and biases. So diverse teams equals better awareness, which overall equals better AI. So now you might be thinking, okay, bias does exist, but is it really that serious? And the answer is absolutely. And here's why. Bias can harm real people. So whether it's denying someone a loan, flagging someone unfairly as a security risk, or misdiagnosing a patient, AI bias does have real world consequences. Also, it can undermine trust. So if people don't trust AI to treat them fairly, they won't use it. And trust is essential for widespread adoption. Also, it's an ethical responsibility. So just because something is technically possible doesn't mean it's morally right. Building fair AI isn't optional. This is a responsibility. And then there are legal and regulatory risks. So governments and regulators are starting to crack down on biased algorithms, and companies that ignore bias, they could face fines, lawsuits, or bans. So that leads us to asking, what can we do about it? Well, bias might be inevitable, but it's not unfixable. So here's how we can fight back. First thing you can do is you can audit your data. So you can look for imbalances, gaps, or historical patterns in your data set, and then ask who is missing and who might be harmed. Then you can balance the training set. So you want to make sure your data sets include diverse examples across age, gender, race, language, geography, etc. You also want to use fairness aware algorithms. So some algorithms are specifically designed to reduce bias. So look into fairness metrics and debiasing techniques during training. You also want to regularly test your model. So don't just look at accuracy, check how well it performs across different groups. If there's a big gap, you want to dig deeper. You also want to include diverse perspectives. So build diverse teams, bring in ethics, social scientists, and community representatives, not just engineers. Also, be transparent. Document your data sources, assumptions, and known limitations, and then publish model cards or fairness reports. Do you want to empower users? So give people some level of control over how AI affects them. Include opt-outs, explanations, and appeal mechanisms. All right, so let's go ahead and wrap all this up. Bias in AI isn't a distant, abstract problem. It's happening right now in systems we use every single day. And if we're not intentional about recognizing it, addressing it, and learning from it, the consequences can be serious. But there is good news. We have the tools, the knowledge, and awareness to do better. So let's build AI that doesn't just work, but works fairly. Let's create systems that don't just scale, but scale ethically. And let's remember that behind every data point is a real person, and behind every algorithm is a choice we get to make, because ethical and responsible AI isn't a feature, it's the foundation. Now, with that being said, let's do some check on learning. So the first question is, which of the following is a common source of bias in AI models? Is it using open source libraries? Is it collecting data only from one demographic group? Is it training a model with high performance GPUs? Or is it choosing a popular machine learning algorithm? And the correct answer is it is collecting data only from one demographic group. So bias this often arises when training data isn't diverse or representative of the real world population. If the data only reflects one demographic, the AI model may underperform or make unfair decisions for underrepresented groups. Next question. An AI system trained on historical hiring data shows a strong preference for male candidates over equally qualified female candidates. What is the most likely cause of this issue? Is it overfitting during model training? Is it data encryption errors? Is it bias that is present in the historical training data? Or is it a bug in the UI design? And the correct answer is bias is present in the historical training data. So if past hiring decisions were biased and the AI model was trained on that data without correction, it will likely replicate or even amplify those biases. And this is a classic case of historical bias in data sets. And our final question is, which practice can help reduce bias and discrimination in AI models? Is it avoiding transparency to prevent misuse? Is it using the largest available data set regardless of quality? Is it relying solely on automated data labeling tools? Or is it auditing data sets and testing model outputs across different demographic groups? And the correct answer is it is auditing data sets and testing model outputs across different demographic groups. So ethical AI development requires auditing and testing for fairness, regularly evaluating both data sets and model predictions across different groups. This helps detect and reduce bias, ensuring the system is fair and responsible. Artificial intelligence is changing the world very fast. From chatbots that sound like real people to smart home devices that know when you're out of milk, AI is popping up everywhere. And while it's exciting and honestly kind of mind blowing, it also raises some very real questions like who's watching what we do online? What happens to the data that we share? And can we trust AI to keep us safe? Now, if you've ever asked, is my data safe? Or how do I know I'm being treated fairly by an algorithm? Then you're already thinking like someone who understands the ethical side of AI. So in this video, we're going to dive deeper to one of the most important topics in AI today, and that is ethical and responsible AI, especially when it comes to data privacy, consent, and user protection. Now, this isn't just about following rules. It's about building AI systems that respect human dignity, rights, and trust. So let's talk about why that matters and what it looks like in practice. Before we dive into the specifics of data privacy and consent, let's answer a simple question. What is ethical AI? Well, ethical AI means designing and deploying AI systems in ways that are fair, where there's no discrimination or bias. They're transparent, so you know what decisions are being made, and there's accountability, so you know there's someone responsible for the outcomes, and they're respectful of human rights and autonomy. Now, these are big ideas, but they're not abstract. They show up in the real world every time an AI system makes a decision about whether you get a job interview, what kind of loan you qualify for, which news stories or ads you see, or how your medical treatment is handled. And when AI impacts people's lives, it has to be ethical. Otherwise, we risk creating systems that are invasive, unfair, or even harmful. And that brings us to the backbone of ethical AI, and that is data privacy, consent, and user protection. All right, so exactly what is data privacy? Well, data privacy is the concept of keeping personal information like your name, address, health records, or even your online behavior safe, secure, and under your control. So every time you search Google, scroll Instagram, or ask Alexa a question, or use a fitness tracker, you're generating data, and that data can be incredibly sensitive. So the question is, who owns that data and what can they do with it? Now, why does this matter when it comes to AI? Well, AI systems, they thrive on data. In fact, data is their lifeblood. But if AI is built using data that was collected without permission or contains sensitive personal details or is stored or shared insecurely, then we've got a serious ethical problem. So imagine an AI health assistant using your medical history, but you never gave permission for that data to be shared. Or imagine a facial recognition app tagging you in photos that you never approved. That's not just creepy, it's also a violation of privacy. And here's a few examples of where data privacy went out the window. So we have what is called Cambridge Analytica back in 2018. And this is where millions of Facebook profiles were harvested without consent and used to target political ads. And that was a massive breach of trust. You also have Clearview AI. This company scraped billions of images from social media and built a facial recognition database without user consent. And ever since then, many countries have banned it. And then there are smart home devices. There have been cases of voice assistants recording private conversations without users realizing it. So these stories highlight why protecting user data is not optional. It is essential. All right, so next let's talk about consent. So what does consent mean when it comes to AI? So in simple terms, consent means giving people control over how their data is collected, used, and shared. But it's more than just a checkbox. True consent must be informed, meaning people know exactly what they're agreeing to. It also must be freely given, meaning there are no pressure or tricks. And it must be revocable, meaning you can change your mind later. So if someone says, sure, you can use my data, but they didn't understand the terms, then that is not real consent. So why does AI need real consent? Well, let's say a company trains an AI to recommend mental health treatments. It uses patient data from therapy sessions, but the patients were never told their information would be used to train a machine. that's not just ethical, it could also be illegal. When it comes to AI, consent must be built into every step of the process. When it comes to data collection, there needs to be something in place to where the user agrees to share their information. When it comes to model training, the users need to agree that their data can be used in certain ways. And when it comes to deployment, does the AI make decisions based on that personal data? Now, without consent, we're essentially saying that you can take what you want and we don't get a say. Now, that is not responsible technology. And then we have these things called dark patterns and manipulative consent. So if you ever tried to opt out of tracking cookies on a website and you found yourself buried in 20 confusing options, well, that's what's called a dark pattern. This is a design trick to nudge you into agreeing without really understanding what you're agreeing to. And ethical AI demands that we avoid these tricks because consent should be clear, simple, and honest. All right, so next let's talk about user protection. So while data privacy and consent are huge pieces of the puzzle, user protection goes even further. It's about making sure AI doesn't harm people, discriminate unfairly, manipulate behavior, or exploit vulnerabilities. So let's go ahead and unpack a few areas where user protection is crucial. The first is bias and fairness. So AI systems, they can reflect and even amplify human biases in the data they're trained on. And some examples could be hiring algorithms that prefer male candidates because they were trained on past hiring data that was gender biased. It can also show up in loan approval systems that reject minority applicants because of historical redlining and credit scores. Now, these are not just technical glitches, they're ethical red flags. So user protection means testing AI for bias and actively working to eliminate unfair outcomes. Then there's transparency and explainability. So if an AI makes a decision that affects you, you should be able to understand why. So for example, why did the algorithm deny your mortgage? Or why did your resume get filtered out? Now, you have this thing called black box AI, and this is where the decision-making process is hidden or too complex to understand, which makes accountability impossible. And ethical AI demands that users are informed and have the ability to challenge decisions. There's also security and data protection. So even if users give consent, the data still needs to be protected from breaches, leaks, and hacks. So imagine trusting an AI with your health data only to have it stolen in a cyber attack. And user protection means implementing strong encryption, secure storage, and access controls. And then there's psychological safety. So AI-driven apps and recommendation engines, they shape what we see, what we buy, and even what we believe. And some examples of this are social media algorithms that promote outrage to increase engagement, or targeted ads that prey on insecurities, or AI-generated content that blurs the lines between fact and fiction. So user protection means designing systems that respect mental health, avoid manipulation, and promote digital well-being. All right, so let's move on and talk about the role of law and regulation. So, ethical AI isn't just about doing the right thing, it's increasingly becoming a legal requirement. And some major regulations that exist are the GDPR, which is found in Europe, and this requires clear consent for data use, which gives users the right to access and delete their data. They have what is called the CCPA out in California, and this offers data transparency and opt-out rights for consumers. And then you have the AI Act, which is going to be coming to the European Union, and this will regulate high-risk AI systems with strict transparency and safety requirements. Now, most countries are following suit, and global companies will need to stay on top of evolving rules, and that's a good thing because it sets a standard that puts people first. Now that we know the why, let's look at the how. Meaning, what can developers, businesses, and students like you do to practice ethical AI? Well, first thing you can do is engage in what is called data minimization. So basically, you don't want to collect more data than necessary. So just because you can collect everything, that doesn't mean that you have to. Also, you want to do privacy by design. So you want to build privacy into the system from day one and do not bolt it on later. So you want to use anonymization, or you want to limit access to sensitive data, and you want to give users control over their own data. You also want to implement consent mechanisms that make sense. So you want to make it easy for users to understand what's happening, choose what they can share, and withdraw their consent at any time. You also want to conduct bias testing and audits. So you want to run regular checks for bias and unfair outcomes. You want to bring in diverse voices during the development process. You also want to have transparent communication. So you want to be able to explain how the AI works and what it does with the user data in layman's terms. But then you want to have ethics committees and oversight. So large projects, they should have ethics boards to review decisions, flag risks, and recommend responsible actions. All right, so here's a quick recap of the big ideas we've talked about. So, when it comes to data privacy, your personal information should be protected and not exploited. When it comes to consent, you should have control over how your data is used. When it comes to user protection, AI should avoid harm, be fair, and keep users informed. When it comes to bias and fairness, algorithms must be tested and adjusted to prevent discrimination. When it comes to transparency, users should understand how AI decisions are made. When it comes to security, you need to have strong safeguards that protect sensitive data. When it comes to regulation, you need to have legal frameworks that are shaping the future of ethical AI. And then when it comes to best practices, developers and companies, they must embed ethics into every stage of AI development. At the end of the day, ethical AI isn't just a technical challenge, it's a human one. We're talking about systems that are shaping our lives in real time. And if people do not feel safe, respected, and protected when using AI, then they simply will not trust it. And without trust, the whole thing will fall apart. That's why practicing ethical and responsible AI isn't just a nice to have, it's an absolute must. It's how we build a digital future that puts people first, and that future starts with you. So, whether you're building the next AI app or just learning the ropes, your awareness of these issues matters. You don't need to be a lawyer or a philosopher, you just need to be someone who's willing to ask questions like, is this fair? Is this safe? And is this respectful? And if the answer is no, then be bold enough to speak up, suggest improvements, or even build something better. Because the future of AI is being written right now, and you're the one that's holding the pen. And with all that being said, let's do some check on learning. So, our first question is, which of the following best describes why user consent is essential when collecting data for AI systems? Is it ensures users are aware of how their data will be used? Is it helps improve model accuracy? Is it is a legal requirement in most programming languages? Or is it reduces the cost of data storage? And the correct answer is it ensures that users are aware of how their data will be used. So, user consent is a core ethical and legal principle that ensures individuals are informed about the data being collected and how it will be processed, stored, and shared. And this transparency fosters trust and protects users' rights. Next question. What is one of the main risks of using personal data in AI systems without proper safeguards? Is it the system will run more slowly? Is it the AI model may fail to generate output? Is it could result in data breaches or misuse of sensitive information? Or is it users may not understand how AI works? And the correct answer is it could result in data breaches or misuse of sensitive information. So, without proper privacy controls, sensitive personal data in AI systems can be exposed through data breaches or exploited in harmful ways, violating ethical standards and privacy laws such as GDPR or CCPA. And our final question is, which practice helps protect users when deploying AI systems that handle sensitive data? Is it training models only with large data sets? Is it using data anonymization techniques? Is it avoiding model evaluation? Or is it collecting as much data as possible? And the correct answer is it is using data anonymization techniques. So, data anonymization, this removes or masks personally identifiable information, helping ensure that even if data is accessed, it cannot easily be traced back to an individual, thus protecting user privacy. All right, so AI is everywhere. It's helping doctors detect cancer, it's powering your social media feed, and it's unlocking your phone with Face ID, amongst a myriad of other things. But here's a question we all need to ask more often. Can we trust it? Because if AI is going to influence what we buy, how we work, who gets loans, or even who gets parole, then we better make sure it's being fair, open, and understandable. So, welcome to the world of ethical and responsible AI. So, in this video, we're going to dive into three critical principles that you must consider when evaluating AI systems, and that is fairness, transparency, and explainability. Now, these aren't just tech buzzwords, they're the foundation of building AI systems that are actually trustworthy, human centered, and socially responsible. So, let's unpack each one in plain language with real life examples, risks, and tips for making AI more ethical. All right, so why do these principles matter? Well, let's go ahead and play out a quick scenario. So imagine you're denied a job interview because an AI screening tool decided your resume wasn't good enough, or you're approved for a smaller credit limit than someone else with similar financials, or a facial recognition system mistakes you for someone else, leading to your arrest. Now, wouldn't you want to know why? You'd probably be asking stuff like, was the system fair and how it judged you? Is the process transparent or is it a black box? And can someone explain what went wrong? Now, these three questions, they get to the heart of fairness, transparency, and explainability. So let's explore each one in more detail, starting with fairness. Fairness in AI is all about making sure systems do not discriminate against individuals or groups based on factors like race, gender, age, or other protected characteristics. But here's the tricky part. AI learns from data, and if the data is biased, the AI can be biased itself. So here's a real life example of this. So a few years ago, Amazon built an AI recruiting tool that unintentionally discriminated against women. The system had been trained on resumes submitted over the past 10 years, and since most of those resumes came from men, the algorithm learned that male applicants were better. Now, what was the result? Well, it penalized resumes that included the word women in it and preferred candidates with more male associated experiences. Now, when it comes to that example, well, fairness was an absolute failure. So let's talk about some types of fairness issues with AI, and we're going to break down a few common problems. The first one is called historical bias, and this is when the data reflects past inequalities. So if an AI is trained on biased outcomes, like hiring mostly white men, it can repeat them. You have what is called sample bias. And this is when the data doesn't represent the whole population. So, for example, an AI trained mostly on faces of light skinned people may struggle to recognize darker skinned faces. And then you have what is called measurement bias. And the way we define success might itself be biased. So, if we define a quote unquote good employee only by sales numbers, we might ignore important traits like teamwork or creativity. So, how do you evaluate fairness? Well, you got to ask yourself, who benefits from the AI system? Who might be harmed? Was the training data diverse and representative? And were different demographic groups tested for equal outcomes? And one powerful way to measure fairness is to run fairness audits. This is where you're testing your model across different groups like race, gender, age, location, etc., to make sure it performs consistently. And sometimes it's not just about fixing the data, but it's about rethinking the entire goal of the system. All right, next let's talk about transparency. So, if fairness is about what decisions are made, then transparency is about how those decisions are made. And unfortunately, many AI systems today are known as black boxes, meaning their inner workings are not visible, even to the people who created them. Now, why does transparency matter? Well, let's go back to our earlier scenario to where you were denied a loan. If the process isn't transparent, then you don't know why you were denied, you can't challenge the decision, and regulators cannot hold the system accountable. And that's a big deal, especially in high stakes areas like healthcare, finance, criminal justice, or education. Now, let's quickly talk about different levels of transparency because not all systems need the same level of transparency. But generally speaking, you have two categories. You got what is called low stakes AI. And this could be something like a Netflix recommender. And basically, it offers some opacity and it might be acceptable. Then you have high stakes AI, and this could be something like medical diagnostic tools to where total transparency is critical. Now, transparency should include things like what data is being used, who trained the model, what decisions does the system make, what risks are known, and what are the limitations. And if users, regulators, or impacted individuals cannot answer these questions, then we've got a serious transparency problem. All right, next let's talk about explainability. So you know what decision the AI made thanks to transparency, but can you understand why that decision was made? And that's where explainability comes in. This is the ability to explain how an AI model arrived at a specific outcome or decision in a way that's clear to a human being and not just a data scientist. Now, why does this matter? Well, imagine you're a doctor using an AI system to recommend cancer treatments. The AI suggests option A, but exactly why? Was it based on the patient's age, their lab results, their medical history, or something else entirely? So basically, you need to trust but verify. And that means you need a good explanation. If you can't explain it, then you can't justify it. And that's a no-go in fields where lives are at stake. So when it comes to AI, you got two types of boxes. You got black box AI, and this is basically a complex model like a deep neural network that offers high performance, but they are hard to interpret. You have what is called a glass box AI, and these are simpler models like decision trees or linear regression that are easier to explain, even if they're not as powerful. Now, there's often a trade-off between accuracy and explainability, but for ethical AI, explainability is non-negotiable in many domains. All right, next, let's talk about some tools and practices for responsible AI. So, now that we understand the why, let's talk about the how. So, how can developers, organizations, and even end users ensure that fairness, transparency, and explainability are baked into the AI systems they build or use? Well, here are a few key practices and tools. The first is called perform bias and fairness testing. So basically, don't just assume your model is fair, test it. And you can use tools like IBM AI Fairness 360, Google's What If tool, and Microsoft Fair Learn. And these tools help identify whether your model is treating certain groups unfairly. You can also use model cards and data sheets. So just like nutrition labels that tell you what's in your food, model cards, they describe what's inside of your AI system. They include what the model was trained on, the intended use cases, and performance across demographic groups and known risks. An example of this is Google's AI model card, where it can help researchers share responsible usage information. Another thing that can help us out is to incorporate explainability tools. And these are now tools that are designed to peel back the layers of complex AI models and provide human understandable insights. So you have a tool called LIME, and that stands for Local Interpretable Model Agnostic Explanations. And this explains individual predictions. You have one that's called SHAP or SHAP, and this stands for Shapely Additive Explanations. And basically, this shows which features contributed most to a prediction. You have what is called Interpret ML, and this is Microsoft's toolkit for explainable machine learning. But basically, these tools help developers and end users make sense of why the AI decided what it did. And then you also want to include human oversight. So AI should assist human decision makers and not replace them entirely, especially in high risk scenarios. So doctors, they should always verify AI diagnosis. Judges, they should always double check risk assessments. And teachers, they should validate AI-based grading tools. And humans, essentially, they must stay in the loop to maintain accountability. And then you want to embrace ethical frameworks. So organizations are developing AI ethics guidelines to steer development. The EU's AI Act is mandates strict transparency and risk standards. You have the IEEE and OECD, where they offer global AI ethics principles. Then you got companies like Google, Microsoft, and IBM. They have their own internal ethics boards, though their effectiveness kind of varies. But the key idea is this: ethics is not optional. It's a requirement for any AI system that touches human lives. Now, to evaluate an AI system's ethics, here are 10 questions that you should ask. Who built the system and for what purpose? What data was it used to train on? Is the data representative of all users? What groups might be harmed by the system? Can the system be audited? Are the decision-making criteria transparent? Can the system's behavior be explained? Is the system accountable to humans? What are the failure scenarios? And how can users contest or appeal AI decisions? Now, if an AI system cannot answer those questions or its creators refuse to answer those questions, then that's a red flag. So here's the thing: just because we can build something with AI doesn't mean that we should. AI is powerful, it's fast, it's scalable, but if it's not fair, transparent, or explainable, it's not responsible. We're not just building technology, we're shaping society. The systems we design today will impact lives tomorrow. So whether you're a developer, a policymaker, a student, or a concerned citizen, you play a role in shaping the future of AI. So ask the hard questions, demand fairness, insist on transparency, and never settle for a black box. Now that we've gone through all of that, let's do some check on learning. So our first question is, which of the following best describes fairness in AI systems? Is it ensuring an AI system performs well on benchmark data sets? Is it making sure AI systems always give the same output for every input? Is it reducing or eliminating bias so that outcomes are equitable across different demographic groups? Or is it preventing unauthorized access to AI models and data? And the correct answer is reducing or eliminating bias so that outcomes are equitable across different demographic groups. So, fairness in AI refers to minimizing bias and ensuring that the system does not discriminate against individuals or groups based on sensitive attributes like race, gender, or age. It's about equitable treatment, not just performance metrics. Next question. What does transparency in an AI system most directly refer to? Is it the ability of AI systems to operate without human intervention? Is it clearly documenting how the AI model was trained and how decisions are made? Is it using open source algorithms only? Or is it allowing all users to modify the AI's source code? And the correct answer is it is clearly documenting how the AI model was trained and how decisions are made. So, transparency means providing insight into how the AI system was built, how it works, what data it uses, and how it makes decisions. This helps build trust and allows for proper evaluation and accountability. And our final question, which scenario demonstrates a lack of explainability in an AI system? Is it a model trained on biased data gives unequal predictions for different users? Is it a chatbot fails to answer a question due to limited training? Is it a loan approval AI rejects an application but cannot provide a human understandable reason? Or is it an AI tool is deployed without user consent? And the correct answer is a loan approval AI rejects an application but cannot provide a human understandable reason. So, explainability means that a human can understand why an AI system made a certain decision. If an AI system makes important decisions like loan approvals without a clear rationale, then it lacks explainability, which undermines user trust and accountability. Artificial intelligence can be cool. It can recommend your next favorite TV shows and help doctors diagnose diseases faster. But what comes with great power? Well, you all know the rest. And as AI continues to become more powerful, more personal, and more deeply woven into our daily lives, we got to ask, are we using it responsibly? And that's where ethical and responsible AI comes in. So in this video, we're going to talk about what it means to practice ethical AI and not just talk about it. We're going to break down the key principles, explore real life examples, and show you what governance really means without the corporate buzzword soup. So by the end, you're going to have a clear understanding of how to make AI that's not only smart, but also safe, fair, and trustworthy. All right. So first off, why does ethical AI even matter? So you might be thinking, if the AI works, isn't that good enough? Well, not quite. AI isn't just a tool anymore. It's making decisions that can impact lives, careers, justice systems, and entire economies. And here's what's at stake. You have AI deciding who can get a job interview, AI determining credit worthiness, AI powering facial recognition for law enforcement, and AI helping courts assess risk for bail or parole. Now imagine if the data feeding those systems is biased, flawed, or incomplete. The consequences aren't just technical, they're human. And that's why ethical AI isn't a quote unquote nice to have, it's a must have. All right, so let's go over the core principles of ethical AI. So there's no universal rule book as of yet, but most ethical AI frameworks revolve around a few key principles. So let me go ahead and break them down. The first one is fairness. And basically, this says AI should not discriminate, period, point blank. But here's the kicker. AI learns from data, and that data reflects the real world. And let's be honest, the real world does have biases, such as historical hiring data that might favor men over women, or police data that might overrepresent certain communities, or facial recognition systems that may work poorly on darker skin tones. Now, practicing fairness, this means auditing training data for bias, testing AI outputs across different demographics, and using inclusive data sets that reflect diverse populations. And then we have transparency. So AI systems, they should not be black boxes. If a system denies someone a loan, they should be able to know why. But many modern AI models, especially deep learning systems, are incredibly complex and hard to interpret. And transparency in practice, it basically provides clear explanations for decisions, which is a field known as explainable AI or XAI. It also documents the model's purpose, limitations, and data sources. And it's also about being upfront with users when AI is being used. Another principle is accountability. So, who's responsible when AI makes a mistake? Is it the developer, the company, or the person who used it. Now, we can't shrug and say that the algorithm did it. Someone must be accountable for the outcomes of AI systems. So, practicing accountability basically, this defines clear roles for decision making and oversight. It establishes appeal mechanisms for users that are harmed by AI decisions, and it maintains audit trails to track AI activity. And then that leads us to privacy. So AI can collect, process, and analyze personal data at scale, but just because it can doesn't mean it should. So respecting privacy means minimizing data collection, encrypting sensitive information, and giving users control over their data, such as opt-ins or deletions. And laws like GDPR in Europe and CCPA in California, they are leading the charge in AI-related data protection. And then our final core principle is safety and security. So an AI that works perfectly in the lab but causes chaos in the real world, well, that's a problem. Safety is about making sure AI does what it's supposed to do without unintended side effects. And security means protecting AI from being hacked, manipulated, or misused. And that includes deep fakes that are used for disinformation. That also includes AI models that are hijacked to produce hate speech. And that also includes facial recognition that is used without consent. Now, all of this is possible and all of it is preventable with strong safeguards. All right, so let's check out some case studies that show why responsible AI is non-negotiable. So let's go ahead and get out of theory and get into reality. And these are examples of AI that were left unchecked that cause real harm. So we have Amazon's biased hiring tool. So in 2018, Amazon had to scrap an AI-powered recruiting tool because it was biased against women. The model had been trained on resumes submitted over a 10-year period, which most of them came from men. And as a result, we penalized resumes that included words like women or female. And so what was the lesson? Well, the lesson was garbage in, garbage out. So biased training data, it will create biased outcomes. Another example is the Compass algorithm in the justice system. So in the US, a system called Compass was used to predict whether criminal defendants would reoffend. It turned out to be twice as likely to falsely flag Black defendants as high risk compared to white defendants. So what was the lesson learned from this? Well, high stakes AI needs rigorous fairness testing, especially in sensitive areas like justice and policing. And then our third example is the Google Photos tagging disaster. So Google Photos once labeled Black individuals as gorillas due to faulty image recognition, which was a catastrophic and offensive error. So what was Google's solution? Well, they removed the word gorilla from the vocabulary entirely. So what was the lesson learned? Well, AI systems, they must be tested on diverse data sets, and companies must be ready to act when things go wrong. All right, so now that we talked about what can go wrong, let's explore how to prevent it. And that's where AI governance comes in. So governance, this might sound like a boring boardroom word, but it's really just about having rules, roles, and responsibilities for building and using AI. So let's go ahead and break it down. So exactly what is governance? Well, AI governance, this is a set of policies, procedures, and structures that guide the development, deployment, and monitoring of AI systems. So think of it as the guardrails that keep AI ethical, transparent, and aligned with human values. And here are the key components of a governance framework. The first component is ethical guidelines. So you want to start with principles like the ones we've covered earlier, such as fairness, transparency, privacy, etc., because they act as your North Star. And organizations like OECD, UNESCO, and the EU have published widely respected ethical AI principles. There's also risk assessments. So just like you assess risk in finance or security, you need to assess risk in AI. And this includes bias risk, legal risk, reputational risk, operational risk. And you want to use a structured process to flag risky models before they go live. There's also model documentation. So every AI model should come with a user manual that includes what it does, what data it was trained on, its known limitations, who tested it, and contact information for concerns, because this improves transparency and accountability. Then there's also the human in the loop element. So for high stakes applications, humans should be involved in critical decisions. Do not let AI run wild. So for example, if AI flags a medical scan as potentially cancerous, then a human doctor needs to make the final diagnosis. And this balance between automation and human judgment is critical. Then there's auditability. So you need to be able to trace how an AI system made a decision. And that's essential for accountability, appeals, and regulatory compliance. So internal and external audits, they will help ensure things are running as intended. And then there's diversity in teams. So who builds the AI matters just as much as how it's built. Diverse development teams are more likely to catch blind spots, ethical issues, and cultural biases. So if your AI team is all one demographic, then that's a potential red flag. All right, so let's talk about governance and practice and who's doing it right. So, we're going to talk about Microsoft's AI principle. So, Microsoft has laid out a strong governance model built on responsible AI standards, ethics review boards, and an internal office of responsible AI. And their AI is vetted at every stage from design to deployment. Then there's Google's AI principles. So, after employee backlash over unethical AI projects, Google now follows guidelines that includes avoiding creating harmful or weaponized AI, promoting privacy, security, and user consent, and incorporating societal benefit into development goals. And then there's OpenAI's charter. So OpenAI, which is the creator of ChatGPT, they publicly commit to ensuring that AGI, or artificial general intelligence, benefits all of humanity. They emphasize long-term safety research, broad dissemination of benefits, and cooperation with other institutions. Now, whether or not any of these companies are going to stick to these principles as commercial pressures rise, well, all of that remains to be seen. All right, so let's talk about regulations. So ethics and governance are great, but sometimes you need laws to back them up. And governments worldwide are starting to step in. So out in the European Union, they have what is called the AI Act. And this proposes a risk-based framework for regulating AI. It completely bans some type of AI like social scoring systems, and it requires strict oversight for high-risk applications like healthcare or education. In the US, there is no comprehensive AI law as of yet, but it is increasing momentum. And President Biden, he issued an AI executive order back in 2023 that focused on safety, fairness, and innovation. And the Algorithmic Accountability Act has been proposed to require impact assessments for automated systems. Now, other countries like Canada, China, and Singapore, they're also rolling out their own AI governance plans as well. All right, so how can you practice responsible AI? Well, this isn't just for lawmakers and big tech companies. You can make a difference, whether you're an AI developer, product manager, student, or you're just curious about the future. So when it comes to developers and engineers, you can always check your data for bias. You can document your models clearly. You can test across diverse user groups, and you can raise ethical concerns within your team. If you're a product manager or a leader, you can set ethical goals early in a project. You can involve legal, compliance, and diverse voices from the start. You can build in time and budget for testing and audits, and you can push back if an AI product feels off. When it comes to students and learners, you can study real-world AI failures and their successes. You can stay updated on ethics trends and regulations. You can question how AI affects different groups, and you can speak up in classrooms and forums. So basically, we're standing at a crossroads. AI is no longer something futuristic or far away. It's here and it's shaping our world in real time. Now, the question isn't just, can we build it? It should also be, should we build it? And how can we build it responsibly? So, practicing ethical and responsible AI isn't about slowing progress, it's about guiding it. It's about making sure that as our machines get smarter, we stay wise. So whether you're coding the next application or you're just learning what AI is all about, remember this: ethical AI isn't a technical problem, it's a human commitment. So let's go ahead and build the future that we actually want to live in. And with all of that being said, let's do some check on learning. So the first question is, which of the following is a core principle of responsible AI? Is it maximizing profit at any cost? Is it promoting data hoarding for competitive advantage? Is it avoiding public scrutiny of AI models? Or is it ensuring transparency and explainability in AI decisions? And the answer is it is ensuring transparency and explainability in AI decisions. So responsible AI, this emphasizes transparency and explainability so that users and stakeholders understand how decisions are made, because this builds trust and accountability in AI systems. Next question. What is the main purpose of an AI governance framework? Is it to automate all ethical decisions? Is it to create marketing strategies for AI systems? Is it to ensure AI systems are aligned with legal, ethical, and organizational values? Or is it to prevent AI from being used in business environments? And the correct answer is it is to ensure AI systems are aligned with legal, ethical, and organizational values. So, governance frameworks they guide how AI is developed, deployed, and monitored to ensure it meets legal standards, ethical norms, and the mission of the organization. And our final question is which of the following best describes the human in the loop concept in responsible AI? Is it human oversight is integrated into the AI decision making process? Is it AI should replace all human decision making? Is it humans should never question AI outputs? Or is it AI should only be used for low risk decisions? And the answer is human oversight is integrated into the AI decision making process. So, human in the loop, this ensures humans remain involved in critical decisions, especially in high risk applications, promoting accountability and ethical integrity.